Welcome, friends. I'm so glad you're here. Whether you're drifting towards sleep, unwinding after a long day, or simply looking for a quiet companion, you've found the right place. Before we begin, I'd love to know, where in the world are you listening from? Perhaps you're wrapped in a blanket sitting by a softly lit window or resting somewhere under an open sky. Wherever you are, I hope you're warm, comfortable, and ready to wander with me into the wide calm the universe reserves for its most spacious rooms. If you find peace or curiosity in these gentle stories, please consider liking the video, subscribing to the channel, or sharing it with someone who might need a moment of stillness too. And to those who've already joined along, thank you. He lets the night open until starlight looks thin, because the story of the Boötes Void begins where galaxies are scarce, and distance itself becomes a kind of element. In the northern constellation of Boötes lies a supervoid, an immense underdensity in the cosmic web, spanning hundreds of millions of light-years across a region so poor in bright galaxies that early surveys circled it on their maps by drawing the outline of almost nothing. The accepted fact rests quietly in the centre. Cosmic voids are real structures, not gaps in observation, and this one is among the largest of the nearby universe, a low-density basin bounded by sheets and filaments where galaxies and clusters collect. He keeps the craft visible so the absence is measured rather than imagined. Redshift surveys march outward in concentric patience, taking spectra of faint smudges, turning wavelengths into distances, and building a three-dimensional ledger of where light lives. Cones of data, once pencil-thin beams through the sky, later wide fans from digital cameras, are rotated in the mind until a lattice appears, its nodes bright, its filaments thin and real, its walls stitched like pale gauze, and here a cavity that holds less than the surrounding average by a margin written in statistics rather than adjectives. The lesser-known detail places itself at the edge like a soft seam. The Boötes Void is not a perfect sphere, but a composite, a set of smaller hollows that expand and merge void into a lumpy supervoid whose boundary is a gradient rather than a shell. A slow climb from very thin to merely sparse. He lets the cosmic web assemble itself so that emptiness has context. In large-scale structure, gravity acts like a long, patient tide. Matter flows away from underdense patches and toward the ribs of the web. Thin gas and faint galaxies drift outward, and the walls grow modestly thicker while the interior grows quieter. Sheets surround the cavity like low shores. Filaments cross like the faintest of bridges, clusters sit at the nodes heavy enough to arrest the Hubble flow locally. But within the broad room, the expansion is the only large weather untroubled by the traffic of rich environments. The quiet mystery keeps a chair where it always does in a good map. How exactly the Boötes supervoid is carved from the initial conditions, how much is inherited from primordial fluctuations imprinted in the early universe, and how much from later evacuation and mergers of smaller voids. Whether a very thin scaffold of dark matter still threads the interior in lines too faint to seed large galaxies. How the few inhabitants found inside acquired their gas and spin without the nudging that crowded neighbourhoods provide. Dry observations settle where they do not wobble. They call the region a void, and it is yet galaxies still live there, only fewer and farther apart. Void does not mean vacuum. They call it empty, and by number density the word works, yet what fills the space, warm to hot intergalactic gas? Dark matter relic. Light is most of everything, only spread so thin that photographs prefer the rim. They call the boundary an edge, while in the arithmetic it is a slope over density, rising gently toward walls, a shoreline of statistics rather than a cliff. He keeps the imagery elemental, so the hollow can be felt without exaggeration. Think of a low-pressure cell on a weather map where isobars relax. Outside winds gather along fronts. Inside air moves outward in quiet drifts. clouds are sparse, calm is not absence of motion, but the shape motion takes when gradients are small. The void is like that, only it is space itself that holds the pressure pattern and gravity that writes the wind. One gentle analogy is allowed and then set down the Boötes. Void is a lake at the head of a delta. After the river has chosen other channels, shorelines remain reeds. At the margins thicken, and the middle lies clear and wide under long light. He returns to the way emptiness is mapped because calm likes a reason. Early slices through the sky, pencil beam surveys found runs of redshifts with long gaps, places where bright galaxies should have appeared if the universe were evenly sprinkled. Later, wide field maps filled the cones with thousands upon thousands of redshifts, and the gap turned into a volume one could trace in any rotation walls on all sides, a cavity inside a handful of dots adrift. The quietness here is proved by counting, not by mood. A lesser poetic detail rests near the rim inside the void. The few galaxies that do live often wear pale disks and narrow bars and form stars modestly blue in tone. Gas still present spirals with long arms that wind without being harried. Quiet laboratories for evolution without frequent tides or ram pressure stripping. He lets the physics of underdensity speak softly so that growth feels like weather. In a region where the average density as low expansion proceeds a little faster, peculiar velocities point outward. Trajectories of test particles, gas clumps, dwarf galaxies tilt away from the centre. Surrounding walls and filaments pull. The void interior becomes even thinner with time. An underdensity deepens as mass drains toward rims, a self-reinforcing ease that the literature names simply and correctly growth of a void. Dark matter participates first and most strongly. Baryons follow slower and with more friction. Stars are the last and least fluid. The quiet picture refuses spectacle and prefers sums over time. Three soft, sleepy ironies find their level and do not insist. Only took mapping everything that glows to discover that one of the largest nearby structures is distinguished by the lack of things that glow. Only required the thinnest region in a survey to become one of the best places to test how structure grows. Only needed making a catalogue of positions to reveal that shape can be learned by subtraction as well as by presence. He keeps the sky's scale in view, so the mind does not lose its footing. Hundreds of millions of light years across belong to the room's diameter. The walls are not hard, the interior is not empty. The few residents do not know they are unusual. They are simply far from neighbours, their night a little darker between local stars. In such a place, a supernova would be a louder event against a quieter field. A faint dwarf would drift longer before tides undo it. A stream of stars torn from a small satellite might write a filament so thin that only a very patient camera could recover it, and even then only as a whisper. He lets instrumentation take a bow because modern calm is measured with modern tools. Hectares of mirrors and millions of fibres make redshift work routine. Weak lensing minute shears in the shapes of distant galaxies draws a grayscale silhouette of mass across even the thinnest places. Subtle absorption of background light by oxygen and hydrogen in the intergalactic medium marks warm filaments too faint to image directly. Together they confirm what the early sparser plots suggested: the Great Hollow is a physical basin in the cosmic web, a room where the universe keeps much of itself in a thinner form. A second quiet detail seats itself with care. The boundary is porous, and at specific corridors between walls, funnel-like passages flow lines converge. There a few galaxies from inside do meet companions coming down filaments, and minor histories precede a small merger, a gas exchange, a spin nudge, events that in a cluster would be common, but here write themselves as footnotes that take a long time to accumulate. He returns to the role of dark energy as a background tone because even the void's calm is carried along by the larger score. Accelerated expansion stretches every moving map. The local group grows more islanded. Supervoids like this become more themselves, with time their rims marching outward in proper coordinates as walls puff and interiors stay thin. The hollow is not an anomaly, but a natural room in a universe where initial ripples have matured into a web with large cells and low-pressure centres. 3 more soft ironies close their eyes where they belong. Only took the weakest of gradients, slightly less matter than average, to write one of the strongest shapes on a cosmological plot. Only required counting where galaxies are not to find a place people remember by name. Only needed gravity, the same gravity that piles mass into clusters to also drain mass from centres and leave a calm worthy of its own map. He leaves the scene as he found it, a dim, spherical quiet in Boötes, outlined not by glow but by its thinning, surrounded by low shores where filaments meet, containing a few blue laboratories where disk and gas evolve without hurry. Fact: the Boötes Void is a genuine underdensity, hundreds of millions of light years wide, mapped by redshifts and supported by weak lensing and models of the web's growth. Detail its boundary as a gradient made from merged smaller voids, and the few inside galaxies tend toward late types with modest star formation. Mystery: the exact origin story written in initial fluctuations and later evacuations, the strength of any residual dark scaffold, and the pathways by which the interior residents keep their gas. Irony's absence becomes a measured thing. The thinnest place teaches growth, and a map of nothing draws one of the clearest shapes in a universe made mostly of things unseen. The room is spacious, the air is even. The story proceeds at the pace the void prefers, quiet, wide, and content to let distance do most of the talking. He lets the first maps come together as lines that turn into rooms, because the discovery of a great hollow begins with spectra, not photographs. The accepted fact rests in the centre without raising its voice. Redshift surveys measuring how much a galaxy's spectral lines are stretched by expansion convert a sky full of angles into a 3-dimensional chart, and in those charts the Boötes Void first appears as a broad, quiet wedge where few points gather. He keeps the craft visible so that mapping an absence becomes a method rather than a mood. A telescope feeds a slit or hundreds of fibre tips. Starlight mixed with the pale glow of gas and dust falls onto a grating. Hydrogen's Balmer lines, calcium's H and K oxygens, forbidden lines, the forest of features in old and young populations all shift. Redward by an amount that becomes velocity, and then, with a cosmological model, distance. Each spectrum is a measured sentence, each redshift a coordinate, each night a handful of dots added to a ledger that, when turned sidewise, becomes a cone in which galaxies stipple walls and filaments and leave, by subtraction, a cavity. The lesser-known detail sits politely at the page's edge, before a gap may be trusted as a void observer's school, their data against illusions, sky emission lines, from Earth's own air that can masquerade as features if subtraction stumbles fibre, crosstalk that can copy a spectrum into a neighbour, and the Malmquist lean that favours bright objects at large distances. Completeness limits are posted like trail signs. Selection functions curve through the plot. Only after such care does a wide, low-density basin deserve a name. He lets history keep a quiet place at the table without turning the room into a museum. Early pencil beam campaigns drilled narrow columns, finding long stretches of redshift with few marks, a hint of architecture and sparse ink. Then broader effort slices several degrees wide, then surveys with thousands to millions of targets, thickened the dots into walls, revealed the web, and left an unmistakable hollow in Boötes that remained rotation after rotation of the cone like a bay the tide refuses to fill. Wedge diagrams, those fan-shaped plots opened like handheld fans. When imagined in the round, the fans traced the shore of a space where almost nothing brighter than modest dwarfs and low luminosity spirals had taken root. The quiet mystery keeps its chair where it belongs, close to the instruments. How much of the Boötes underdensity is simply primordial, an initial low in the random field of early fluctuations stretched to present scale? And how much is the result of later dynamical evacuation as surrounding sheets pulled material outward over billions of years? The formal language is familiar growth factors, transfer functions, watershed algorithms that segment emptiness like basins on a topographical map. Yet the detailed partition between inheritance and evolution remains a distribution with room for debate. The void is older than any catalogue, but younger than the initial noise. Dry observations walk 3 level stones into place. They call wedge plots pictures, though the pictures are made of distances inferred from line shifts, not of light itself. Seeing here means measuring. They call the hollow spherical, and in gross outline it is yet the boundary is a slope built from smaller voids stitched by expansion, more gradient than edge. They call the interior empty, but spectrographs still find a handful of residents, blue spirals with thin arms, low surface brightness. Disks, and dwarfs that in a crowded place might be quick to lose gas. Here they keep it. He keeps the imagery elemental, so the chart can be pictured without romance. The cone is a slice of air from a weather map. Pressure lines bend and concentrate at fronts. Between them calm spreads. Rotate the slice and the calm becomes a 3-dimensional room. One gentle analogy visits once and rests a redshift survey as a sonar in a clear lake. Echoes from fish and reeds make bright streaks. The middle where water is only water returns little. The quiet is the shape. He returns to the arithmetic of making emptiness trustworthy, not dramatic. Sky subtraction removes the night's own neon from the spectrum. Flat fields make detectors honest. Flux calibration keeps blue and red in proportion. Galaxies fainter than a limit are acknowledged, but not expected to alter the verdict. Statistical void finders watershed in density fields, spherical, underdensity thresholds, tessellations that assign each galaxy a cell and then mark the cells that are large agree on the presence of a basin, even if they differ on the exact rim. Weak cleansing. A second ledger adds weight. Shapes of background galaxies suffer minute coherent shears even in underdense regions. The sign is the mirror of a clusters. Together redshifts and lensing confirm that the boat's hollow is not a hole in the data, but a basin in the mass. A second precise detail lays its small tag without fuss. The interior's few galaxies are not randomly scattered. Some align along wispy filaments, tendrils that span the void substructure that theories of void subvoids and tunnel-like channels anticipate. Those threads are too slender to summon many cities, but sufficient to guide the handful of roads that exist. When mapped in 21 centimeter light from neutral hydrogen, some of these dwarfs show extended gas disks undisturbed by ram pressure, an everyday fact in a void and a rarity near a wall. He lets kinematics turn the static picture into weather. Peculiar velocities motions relative to pure expansion tend to point outward inside an underdensity. Near the rim they veer towards sheets. A galaxy at mid-radius feels a long, low pull toward the nearest wall. Its line of sight recession is a little faster than Hubble's law would give at the same distance if the universe were homogeneous. The difference is not dramatic in any one case, but statistically the fingers of motion taper away from the center. Flows of gas in the intergalactic medium trace the same trend, warm filaments thin toward the middle. Metals oxygen and neon in ionized states that speak in ultraviolet are rarer there because fewer supernovae have sprayed their furnaces into such quiet air. 3 soft ironies find their level and lie down. Only took the most advanced spectrographs and largest catalogues to prove a negative space one of the clearest results in the map is the part with the fewest dots. Only required the thinnest environment to preserve the fullest neutral hydrogen disks in some small galaxy's emptiness protects fuel. Only needed the universe's tendency to pile matter into walls to write as a shadow, a room distinguished by what never collected. He keeps the edges in view because edges are where categories meet. The boundary of the Boötes hollow is not a cliff but a rise. Density contrast builds over tens of megaparsecs. Near it, dwarf galaxies begin to show signs familiar from busier districts. Mild asymmetries, the first whispers of past tides. In corridors where filaments thread 2 neighbouring walls, a few intermediate mass spirals carry the stamps of minor encounters that would have been major in a cluster and trivial in a sheet. Here, a single close pass is a story that might define 1 billion years. A lesser poetic detail sits on the sill in deep imaging. The rim's richer groups throw pale intergalactic light, outward ghost halos that overlap the void like a fog that stops where dew cannot form. The middle stays drier, and its dark is darker for it. He returns to catalogues because the quiet shape becomes truer as lists lengthen. Early compilations carried thousands of redshifts and a large error bar on the void size. Later surveys, digital wide deeper, reduced the noise and kept the hollowness. Cross-matching with radio catalogues added gas-rich dwarfs to the handful inside. Ultraviolet maps found star-forming knots where little else agreed to settle. X-ray limits remained low in the interior as expected where hot intra-group media are rare. With each pass, the hole in the map refused to fill. Dry observations resume their even pace. They call the Boötes region special, and in one sense it is. In another, voids of many sizes pock the web and statistics of their sizes. Shapes and alignments provide tests of expansion that rival cluster counts for leverage. They call the rim rich, yet by cluster standards it is modest. What makes it bright is contrast with the middle. They call the interior quiet, and for star formation in neighbours it is. For cosmology it is lively, an essential baseline for what structure means. He keeps uncertainty where it belongs, and no larger. Models differ on how sharply the interior's density drops relative to the mean. The location and number of tendrils vary with algorithm and threshold. The early universe's exact imprint on this particular supervoid is reconstructed rather than observed. None of these soften the broad picture a basin exists. It is large. It is part of a network of hollows and walls, and it was chiselled by the same gravity that raised the walls. One gentle analogy closes the loop and rests. The wedge plot becomes a lantern held to a paper screen. The cutouts holes where paper is absent are as informative as the parts left behind. Turn the lantern and the holes keep their shape. Walk farther back and the holes enlarge slightly but remain holes. Approach and their edges soften. Either way the pattern is true. He lets the sections sit where evidence weighs more than adjectives. Fact, redshift surveys corrected for selection and calibrated against lensing and gas tracers reveal a super void in Boötes, an immense underdensity whose boundary is a gradient, and whose interior hosts only a sparse retinue of small, often gas-rich galaxies. Detail verification requires disciplining skylines, completeness and bias. Tendrils inside a line along thin filaments. 21 centimeter maps find extended neutral hydrogen where crowded places would have stripped it. Mystery, the precise share of primordial underdensity versus later evacuation in carving this basin, and the fine topology of any dark scaffold that still threads the interior. Ironies, the clearest map feature is made of nearly nothing. The emptiest room preserves the fullest disks, and the same gravity that builds walls also hollows rooms. The cone closes, the dots remain few, the great hollow keeps its tone measured, thin, and entirely content to be verified by counting. He lets the lattice come into view the way frost turns a window into a map, because the Boötes hollow only makes sense when the web around it is allowed to stand. The accepted fact sits quietly in the middle. On the largest scales, matter organizes into a cosmic web, filaments and sheets that meet at clusters and surround many voids. Gravity draws mass along tidal slopes from the centers of hollows toward walls, so the void's calm is framed by rims that slowly grow. He keeps the craft visible, so web becomes process rather than metaphor. In the Zeldovich picture, overdense directions collapse, first turning volumes into sheets and sheets into filaments, while underdense directions expand. Later, adhesion-like physics, an approximation to real dissipation, keeps caustics from uncrossing and preserves the skeleton. What the eye calls a wall is really a place where trajectories intersect and slow, where flows from several voids meet and stack. What the mind calls a filament is a line that separates two or more expanding basins, a ridge raised by the absence on both sides. He lets velocity fields speak because in this landscape motion is a map. Inside void's divergence is positive streamlines drift apart. At walls divergence flips sine. At filaments shear takes over. Near nodes convergence dominates. Peculiar velocities trace these trends. Galaxies in the Boötes interior tend to drift outward, relative to pure expansion. Near the rim they turn and slip along a sheet toward a brighter junction. Small test particles, gas clumps in the intergalactic medium follow similar slopes, their paths set more by potential than by collisions. The lesser-known detail sits modestly at the edge, like a thin line in pencil watershed algorithms used to segment the density field into basins, show that the Boötes supervoid is stitched from several contributing subvoids, each with its own center and flow lines. Their shared boundaries define the walls that observers catalogue as surrounding groups and low clusters. Where 3 basins touch a filament rises, where 4 share a corner a node gathers. The geometry is discrete even when the light is faint. He lets the room be drawn with gas as well as stars because the web is mostly air the eye cannot see. The intergalactic medium here is warm to hot and thin. Oxygen in mid and high ionization states absorbs background ultraviolet faintly. Hydrogen leaves only the weakest Lyman alpha signatures. In X-rays the glow is near the limits of patient instruments. Along the rim where density climbs, emission strengthens a little. Within the filaments, temperatures and densities are just high enough that shocks have passed and left gentle heating. Metals are more common there than in the middle, written by winds from galaxies that live on the banks. He lets these threads guide a hand outward to the walls. Sheets present as broad, low-contrast panels of galaxies, each with its own internal groups and small knots. Their thickness is tens of megaparsecs. Their surfaces are not smooth but quilted by lesser filaments that lie almost within the plane. In the direction where the Boötes rim meets a neighbour void's rim, the sheet is a watershed between basins stepped to either side, and the downhill is a different hollow. Edges are gradients, even gradients suffice to turn flows. The quiet mystery keeps its seat how much of the web's present skeleton is inherited in detail from primordial phases, peaks and troughs convolved with transfer functions, and how much of the fine carving within walls and filaments owes to nonlinear feedback from baryons, outflows, shocks, magnetic fields that push and cushion in ways dark matter alone would not predict. Simulations include both and match coarse structure. The grain remains a place where models negotiate with new surveys. Dry observations place 3 flat stones that do not wobble. They call the web foam, and the image helps, but the physics is not bubbles crowding as much as trajectories folding in a common potential. They call the walls solid, yet their galaxies are separated by millions of light years. Solidity is a count, not a touch. They call voids empty, but most of the universe's volume lives there, and most of its mass passes through walls so slowly that the words interior and boundary matter more in patience than in principle. He keeps the imagery elemental so the bay can be pictured without drama. Think of a broad, shallow estuary at low tide. Water flows out from many small creeks, spreads thin and quiet, then finds channels deeper seams that lead to the sea. The Boötes Void is the estuary's flat water. The walls are the bar-shaped sandbanks where streams meet. Filaments are the channels. Clusters are the points where currents knot. One gentle analogy breathes once and rests the void as a high-pressure system on a weather map. Air drifts outward from the centre, and along the fronts, walls and filaments clouds collect. He returns to kinematics because the bay's shape is better heard than seen. Galaxies just inside the rim feel a small outward push from the underdensity and a stronger side pull toward the wall. Over billions of years, this tilt moves populations thickening the bank while thinning the middle. Velocity caustics lines in phase space where many trajectories crowd form along filaments. Even in a thin region like Boötes, those caustics exist as mathematics, if not as bright marks. They tell why sparse threads still guide the few residents. A second precise detail pins a tag beside the wall. The compensation around large voids and overdense ring, where mass swept from the interior accumulates, is measurable in stacks. Profiles that rise above the mean before relaxing are common. In boats, compensation is present but modest, consistent with a supervoid assembled from several basins rather than a single perfectly symmetric hollow. He lets the walls teach by contrast what the interior cannot by itself. In sheets, galaxies interact more often. Small groups share intra-group gas hot enough to glow. Ram pressure trims neutral hydrogen disks. Star formation histories show more bursts and pauses. Bars are common and sometimes younger. The difference is not morality, it is boundary conditions. Remove tide and wind and a disk's fate lengthens. Add them and the same disk writes a busier journal. The interior's handful of galaxies in Boötes wear this difference like a quiet posture, more gas per unit stellar. Mass, later type morphologies, specific angular momenta on the higher side for their mass. Three soft ironies find their level. Only took counting where matter collects to see that the shape of nothing is drawn by where something insists on being. Only required the quietest part of the map to make the directions of motion clearest outward in the middle sideways near the rim downward at the nodes. Only needed the thinnest air to make the longest free paths for light, and yet the light remains scant because the web does not put cities in the middle of lakes. He keeps dark matter present because scaffold precedes brick. Weak lensing reconstructions across this region hint at faint bridges, mass without many stars threading the interior and tying walls at a few points. The signal is small and the uncertainties large, but the pattern fits expectations. Even a supervoid has a flaw, not a hole. Even a flaw has a grain, not a polish. If the floor were smoother, tendrils would be rarer still. If rougher, more dwarfs would trace it. The quiet mystery returns in that sentence. How rough is the floor really? And at what scales does roughness matter for galaxy birth when neighbours are far? He returns to methods because calm prefers instruments to adjectives. Surveys as divide the sky into redshift shells and compute density contrasts. Tessellations give each galaxy a cell. The largest cells cluster into voids. Their boundaries trace walls. Their intersections flag filaments and nodes. Stacking many identified voids produces an average profile deep center rising rim. Modest compensation that matches Boötes in shape if not in sheer size. Radio maps at 21 centimeters add gas. Ultraviolet absorption toward background quasars gives temperatures and metallicities. Together, these draw a minimal but sufficient weather report for the interior warm, thin, slightly metal poor with modest flows along faint gradients. Dry observations return to their even pace. They call filaments bridges, which they are, yet most traffic is gravitational drift, not passage with purpose. They call nodes cities, which helps, but a city here is a potential well with a long census cycle, not a street plan. They call the whole a sponge, yet unlike a sponge, the web drains rather than soaks interior to rim to line to knot. He keeps one more lesser detail on the sill alignments. In void environments, galaxy spins show hints of different statistics. Late-type disks sometimes align their spins with local filaments. In richer environments, alignments tilt another way. The signal is weak, the survey's still arguing, but if real, would be one more example of the web's grain setting a rule where chaos might be expected. He lets the section settle where structure speaks in its own voice. Fact, the cosmic web surrounds and defines the Boötes supervoid. Matter flows outward, inside along sheets at the rim, and down filaments to nodes. Walls thicken as basins extend and merge. Detailed watershed algorithms reveal the void's composite basins. Compensation around its rim is modest. Warm, thin wool and faint dark bridges thread the interior. Spin alignments and tendrils hint that even emptiness has a grain. Mystery, the fine partition between primordial imprint and late carving, by baryonic feedback in setting the web's grain here, and how that grain regulates the few galaxies that stay. Ironies, walls draw the shape of nothing. The calmest room shows the clearest arrows. The thinnest air grants the longest view but the fewest lamps. The bay remains level, the shores keep their low relief, and the lattice, which looks like architecture to the eye, continues to be what it has always been, a patient rearrangement of motion under a field that never raises its voice. He lets the shape take its time to appear, because in the Boötes hollow, geometry is not a pose, but a slow consequence of motion. The accepted fact rests in the centre without raising its voice. The Boötes Void is only roughly spherical. Its true figure is lumpy and layered, a supervoid assembled from smaller overlapping basins whose boundaries are gradients rather than edges, so that any radius is an average over slopes, not a circle drawn on glass. He keeps the craft visible so that form follows field. Matter evacuates more quickly along directions where surrounding walls pull hardest. Where two neighbouring voids touch the saddle between them, thins and then melts, and the joined basin inherits an indented waist. Where three expand together, the seam becomes a faint filament that survives inside as a thread. What looks round in a shallow map becomes ellipsoidal in a deeper one, and then becomes a composite in the full ledger. A nesting of hollows that share a quiet centre but disagree on where exactly the rim begins. The lesser-known detail sits cleanly near the margin stacked profiles of many voids, scaled by an effective radius that equates their volumes to spheres, often follow a universal curve, an underdense core, a gentle rise, and then a compensating ridge, just beyond the nominal edge, where mass swept from the middle gathers before relaxing toward the cosmic mean. Boats oversized and made from several basins shows the same grammar with broader vowels, a deeper, wider interior, a low extended shoulder, and only a modest compensation because its rim is shared among neighbours and does not collect into one tight ring. He lets coordinates rotate so the figure can be felt as more than a cross-section, slice the supervoid along one great circle, and the interior looks broad and plain. Turn the plane and a faint waste appears where two ancestral basins still leave their signature. Turn again and a tongue of slightly higher density reaches inward, a remnant of a wall that once separated subvoids and now survives as a barely there bank. In 3 dimensions, the shape moves between a rounded ellipsoid and a laced bowl. The lace being tunnels, low-density corridors that run through a thin network connecting one rim to another. The quiet mystery keeps its chair and refuses to hurry what sets the preferred orientation of this lumpy ellipsoid relative to the surrounding web. Do the long axes of the supervoids align with the slowest principal stretches of the tidal field in this region? Do the inner tendrils mark old seam lines or new flows? Simulations suggest alignments. Surveys hint at them. Proofs remain a matter of stacking many hollows and listening for a chorus in the noise. Dry observations lay 3-level stones. They call the void nearly spherical, and at first glance that is serviceable. Yet the fit with an ellipsoid leaves residuals that matter because the shape's slight squashes and stretches record how forces differ by direction. They call the edge an edge, and yet no galaxy crosses a boundary, as if stepping over a curb. Density rises over tens of megaparsecs, a slope that refuses to become a wall. They call the middle centered, but even the centre is a patch with subtle relief tendrils that thread saddles that slouch, and a floor that is grainy rather than polished. He keeps the imagery elemental so unevenness feels like weather not floor. Think of snow settling across a field where wind is not uniform. Some drifts are round, others stretch along fences you cannot see at first. Where 2 breezes meet a saddle forms, where 3 meet a little rib runs downwind. Walk the field tomorrow, and the largest shape is the same while the thin relief shifts by inches. The void is that field and gravity is the wind. One gentle analogy breathes once and rests. The supervoid is a basin carved not by water, but by the absence of water. Rills and saddles remain in the dry earth and tell you how the last rain ran away. He returns to the arithmetic of radius because calm prefers a definition before a word, an effective radius. Ref is defined by volume. Take the total low-density volume assigned to the basin and imagine a sphere that would hold it. Ref is that sphere's radius. Observers report distances in units of ref so that different voids can be stacked and compared. But in any one system, including Boötes, a spherical cut at ref intersects levels that a gradient does not respect along one direction. The actual rim is outside ref along another, inside it. Profiles plotted in these scaled units smooth the truth into a universal curve. The local reality retains a face with character low on one cheek, a little higher on another, a dimple where subvoids merged. The second precise detail takes its seat with modest clarity when voids are examined. In redshift space, peculiar velocities stretch or squash them along the line of sight. Outflows make them appear slightly elongated toward the observer at certain scales and squashed at others. Correcting for this distortion retrieves a more faithful figure, and in stacks has been used to test cosmological distances through a geometric trick that asks whether the average void looks the same along and across the line of sight. For Boötes, the correction affirms what maps already say: the real space figure is not a perfect ball. It is a layered bowl whose lip is higher in some azimuths than others. He lets mass speak where light will not. Weak lensing measures the integrated deficit of mass in projection. In the Boötes direction, the convergence dips gently below zero over angles that track the void's sky footprint, and then rises toward the rim. The dip is neither deep nor sharp. It is broad and persuasive, matching a 3-dimensional underdensity, whose centre sits near the same redshift as the hollow drawn by galaxy redshifts. In the interior, the inferred overdensity reaches negative values of order, a few tenths below the mean thin but not nothing. At the rim, the climbs and modestly overshoots. Farther out it relaxes. That simple contour below, then a shoulder, then calm, recurs whenever the figure is traced by independent ledgers. 3 soft ironies settle where they belong. Only took averaging many hollows to claim a universal shape, and then The specimen most people name turns out to be the exception that proves the rule by being close but not exact. Only required defining a radius by pretending to be a sphere to learn that the important parts are the places where the pretense fails, dimples, saddles and threads. Only needed the line of sight blur introduced by motion to help remove itself and reveal that round enough conceals instructive slants. He keeps substructure visible because a large room made of smaller rooms remembers its joins. Subvoid centers inside Boötes can be labelled by where local density is lowest within each basin. Flow lines traced from saddle points between them run along faint corridors toward the rim. Galaxies that happen to live along those paths share orientations and spins that whisper of the filamentary grain. If a dwarf forms in such a trough, its gas disk grows large and lightly sheared. If a slightly more massive spiral sits in a saddle's lee, its star formation proceeds with few interruptions. If a small group resides near a tunnel that opens into a wall, its members show the only modest hints of past tides the interior can offer. The quiet mystery returns in the persistence of these joins. How long do seams survive after basins coalesce? Do they guide gas flows in the intergalactic medium for longer than they remain obvious in galaxy counts? Do magnetic fields dragged into place when the hollows merge scaffold these corridors beyond what density alone would predict? He returns to method because geometry here is found not announced. Watershed algorithms treat the density field like a topographic landscape and fill basins from the bottom up. When two rising lakes meet at a pass, the line between them is a watershed. Follow those lines and an irregular polygonal skeleton outlines a supervoid that is far more honest than any circle. Tessellations give each galaxy a cell and assign volumes to emptiness that light ignored. Stitching large cells together recovers rooms. Assigning effective radii then allows stacks which in turn reveal universal curves. But it is the unstuck view, the polygon, the seam, the tunnel that teaches how this room, not a typical one, was carved. Dry observations resume their even pace. They call the Boötes hollow one void, and so it is by name. Yet in the ledger it is a family reunion, several basins, one table. They call the rim the border, though borders here are bands not lines. A galaxy moving outward does not cross a fence, it climbs a long, low hill. They call the figure simple because round shapes comfort the eye. The field prefers a modest complexity that remembers how the past flowed. He keeps one more lesser detail on the sill. If the ellipsoid is fitted with principal axes, the longest axis often lines up with the nearest corridor between two brighter walls. That axis is also the direction along which peculiar velocities show the cleanest outward component. The void's longness, such as it is, points toward the path of least resistance, an expected, almost tautological result that nonetheless pleases, because the map and the wind agree. He lets the section settle where shape motion and method agree more than they argue. Fact. The Boötes Void is not a perfect sphere, but a composite, lumpy supervoid whose profile shows a deep, broad interior, a gentle rise and a modest compensating ridge. Redshift space distortions and weak lensing, corrected and combined, confirm a layered bowl with tunnels and seams. Detail effective radii and stacked universal curves aid comparison. Watershed and tessellation methods recover polygonal, truthful outlines. Principal axes tend to align with low-density corridors between walls. Mystery how persistent the inner seams remain as guides to gas and spin. How the void's principal orientations reflect the tidal field here. And how much the lumpy floor, even where door is small, regulates the few galaxies that stay. Ironies, a sphere helps define a shape that is not spherical. The useful edge is a slope, and motion's blur helps measure motion's cause. The great room keeps its uneven floor, the lip lifts higher in some azimuths than others, and the map, which began as a fan of dots on paper, now reads like relief, traced by calm, thin and content to be round enough only where round is the least interesting thing about it. He lets the inhabitants appear at their true scale, because the best way to see a void is to watch what refuses to leave. The accepted fact rests quietly in the middle galaxies do live in the Boötes hollow, fewer than elsewhere, widely spaced, often late-type low-mass gas rich and blue. They form stars modestly in extended disks and evolve with fewer interruptions than cousins at walls and nodes. He keeps the craft visible so that solitude looks like physics and not romance. In thin environments, cold gas survives longer. Ram pressure from intragroup media is rare. Close passages that stir bars drive inflows and truncate outer gas are infrequent. Neutral hydrogen spreads into wide, low-surface density disks. Rotation curves rise gently. Specific angular momentum runs high for the mass. Star formation proceeds below fireworks, patchy H2 regions along loose spirals, ultraviolet knots where gas surface density tips above the familiar thresholds. Metallicity sits a little low for the same stellar mass compared to busier neighbourhoods, a chemical echo of fewer past starbursts and more pristine inflow. The lesser-known detail sits at the edge, like a thin line on a clear page inside some voids, including corridors within Boötes. Small chains of galaxies align along wispy filaments, 3 or 4 dwarfs or faint spirals sharing a thread of neutral hydrogen, their velocities nearly collinear, a miniature web within the lac. In such threads, gas bridges appear in 21 centimetre light, even when optical light remains shy, as if the void's floor prefers to write its grammar in hydrogen first and in stars later. He lets the disks speak because in quiet rooms disks keep their shape. Without frequent tides, warps are mild and bars, when present, are slower to strengthen. When bars do exist, they often arise from internal instabilities and grow on longer clocks. Tumra's Q hovers near stability across broad and newly. Outer disks show low-level star formation that would be quenched by even modest harassment in a wall. Flares at the edge where thickness grows with radius record low vertical heating. In the centres, circumnuclear rings are rare and small, no crowded queue of inflows demands attention. Star formation histories read from colours and absorption lines lean continuous rather than bursty. Quenched dwarfs are scarce. Green Valley pauses are less common. He lets chemistry and gas kinematics steady the picture. Oxygen abundance at fixed mass trends lower. Nitrogen rises more slowly. Gradients are shallow, partly because mixing over large undisturbed disks proceeds long enough to smooth, and because infall of low metallicity gas still happens at the outskirts. Shyline profiles are narrow, double-horned shapes when present trace extended fairly symmetric rotation. Asymmetric profiles, though not absent, are less often the scars of tides and more often the signatures of lopsided accretion or long-lived modes. Molecular gas forms where dust is sufficient and pressure high mainly in inner disks, and even there the ratio of molecular to atomic gas can be smaller than in walls. The quiet mystery keeps its chair how void galaxies acquire and keep their gas without the usual supply lines from crowded filaments. Does the faint dark scaffold crossing the interior drip small cold clumps over long spans? Does smooth low metallicity inflow condense in boundary layers where the disk's halo brushes the tenuous medium? Do the thin tendrils channel gas episodically so that what looks like continuous fueling is really light rain in long intervals? Simulations suggest all 3 paths: measurements absorption toward background sources, faint halo emission, and delicate kinematics accumulate slowly. The ledger remains a calm invitation rather than a conclusion. Dry observation set 3 even stones. They call these galaxies isolated, and by counts they are. Yet isolation here is a distribution long times between encounters, not an absolute refusal of company. They call them unevolved, but unevolved mostly means uninterrupted. Old stars are present, disks have histories, only the punctuation is sparse. They call them blue, and many are, yet the blue is a low flame-specific star formation rates are higher at the least masses, but not luminous bursts. The colour is patience, not spectacle. He keeps the imagery elemental, so the residents can be pictured without drama. Each galaxy is a small fire in a wide plain. The woodpile is larger than the flame requires. A breeze brings new twigs seldom and evenly. No passer-by steals fuel or kicks ash. The hearth persists. One gentle analogy breathes once and rests a void spiral, is a windmill on a broad prairie turning steadily, grinding slowly dependent on a large sky, rather than on nearby currents. He returns to distances because they write both calm and constraint. Nearest bright neighbours sit millions of light years away. Groups where they exist at all are pairs or trios with long crossing times. Escape speeds are low. Dynamical friction is weak. Satellite systems around these small hosts are thin or absent. In such a registry, a minor merger is an epical event. A cold stream landing at the right angle is a chapter title. Harassment is a word that never earns a paragraph. The second precise detail sets a tag on the disk edge. Extended ultraviolet XUV disks. Faint UV emission beyond the traditional optical edge appear disproportionately among void spirals, marking in situ star formation at surface densities so low that only in thin environments do gas and gravity agree long enough to gather. The UV rings and patches in these outskirt servers, testimonies that cool gas still arrives and that stability is a moving line, not an absolute. He lets outliers take a careful seat because exceptions teach the grammar. A few early-type galaxies live in the hollow, faded disks or small spheroids with old light likely imported from the rim by chance or born from a rare major merger along a tendril. Their scarcity is the lesson. Ultra-diffuse galaxies with large sizes and low surface brightness are uncommon but not forbidden. When present, they often carry gas and form stars softly unlike their quenched cousins in clusters. Low surface brightness giants, on the other hand, can claim the space giant HI disks with feeble starlight, their stability a quiet balance between high spin and low pressure. Three soft ironies find their level. Only took the least crowded county in the universe to preserve the most generous HI disks. Only required a near absence of tides to let the thinnest outskirts become the places where stars still begin. Only needed a lack of neighbours to make a passerby. Once in a few billion years count as a major life event. He keeps bars and spirals in view because patterns that elsewhere are driven by chorus here are solos. In many void disks, spiral structure is flocculent, patchy, multi-armed, and quietly self-propagating. Where a grand design pattern appears, its drivers are internal swing amplification and cooling rather than imposed by a near companion. Bars, when present, thicken slowly and may remain weak. Gas inflow along bar dust lanes proceeds, but at rates that keep circumnuclear fuel low. Rings in or outer resonant occur, yet their symmetry hints at a long life without kicks. Star clusters are fewer and less massive on average. Their disruption is gentler. Tidal fields do not add extra terms. He returns to halos because the ceiling matters as much as the hearth. The circumgalactic medium around a void spiral scales to the same physics gravity cooling feedback, but its exchange with the larger intergalactic medium faces fewer shocks. Metals ejected by supernovae travel farther before mixing. The halo's entropy is set by internal events more than by group weather. Cool clumps that condense fall in on long, slow paths misaligned enough to tilt outer disks and seed warps that never grow severe. Flares and ripples at large radius remember each arrival for longer than they would in a busier place. The quiet mystery returns there too, where the cosmic rays and magnetic fields play a larger stabilizing role in low-density surroundings, cushioning inflow and stretching star formation over longer spans. The theory expects some contribution. The measurement is delicate and still thin. Dry observations resume their walk. They call void galaxies field and mean it in the sense of open country. The label is not a dismissal but a duty. The field sets baselines for how disks behave when left to themselves. They call the population biased more late types, more dwarfs, and the bias is a map of history, rather than a quirk dynamical growth, builds big things at the rims first. They call the sample sparse, and sparse is the point. Significance arrives by stacking patience over many rooms like this. He keeps one human-scale image on the sill to steady proportion. A person under a dark sky inside such a galaxy would see fewer bright neighbours and more dark between them. The Milky Way's crowded lanes are absent. The zodiac of nearby suns is thin, yet the local night stars of one's own disk remains full enough to learn calm. Telescopes on such a world would inventory gas. Before they exhausted galaxies, the nearby sky would be a school for hydrogen. He lets the section settle where inhabitants and Hollow share one weather. Fact galaxies inside the Boötes supervoid are sparse, typically late-type gas-rich and modestly star-forming, with high specific angular momentum extended HI disks and fewer signs of past harassment. Detail metallicities at fixed mass trend low. Gradients are shallow, XUV outskirts are common. Narrow HI profiles and symmetric rotation curves reflect undisturbed kinematics. Miniature filaments thread small alignments and gas bridges. Mystery the precise fueling channels, smooth inflow versus clumpy rain along tendrils, and the roles of magnetic fields and cosmic rays in stretching star formation across long spans when neighbours are scarce. Irony's emptiness protects fuel. The thinnest outskirts host the last new stars, and the rare encounter in a void writes a louder signature than a dozen in a wall. The residents keep their sea work, the floor stays thin, and the Hollow judged by what stays proves that quiet is not the lack of life, but the space it uses to proceed without haste. He lets departure be the grammar, because in a Hollow the most faithful motion is away. The accepted fact rests in the middle, without asking for emphasis in an underdense region. Peculiar velocities point outward. Matter drifts from the void's interior toward its surrounding sheets and filaments, so the center evacuates while the rim thickens, and the contrast between middle and edge slowly grows. He keeps the craft visible so that leaving means vectors and not a mood. Write the density contrast as says dra ra, where thou is negative linear. Theory says the divergence of the peculiar velocity field is positive. Trajectories separate, not crowd. In the Boötes Hollow, this field is not dramatic in any one place. It is insistent in some. Test particles, gas clumps, dwarfs, faint spirals trace streamlines that slant away from the center. Near the rim they arc sideways along sheets, then slope down filaments toward nodes. The void's interior expands a bit faster than the background. The term superhubble outflow is a quiet way of saying that clocks in the middle measure a slightly larger recession per unit distance than the cosmic mean once peculiar motion is included. The lesser-known detail sits neatly by the lip mass swept from the interior does not vanish. It raises a compensating ridge just beyond the nominal void edge, a band of mild over-density that can overshoot the mean before relaxing, measurable in stacked profiles, and hinted even here as a low, broad shoulder rather than a single ring, because Boötes merges several basins and shares its rim with neighbours. He lets the evacuation write itself across different ledgers, so departure feels like weather. Weak lensing read shallowly across the region shows a gentle deficit in projected mass over angles that match the Hollow. The deficit lifts toward the edges and modestly above zero where compensation collects. Void galaxy redshift space correlations turn round spheres into mild ellipsoids along the line of sight. The anisotropy matches outflow when models fold motion into distance. Even temperature maps of the microwave background stacked on many voids show the faintest of imprints, an integrated shift that fits a universe in which potentials evolve. Subtle, disputed in places, but in the aggregate one more whisper that emptier rooms do different work to light passing through them. He lets the rims rise become a story of gentle gathering. Sheets surrounding the hollow are not walls in the masonry sense. They are regions where flows from several basins meet and slow. Their intra-group media can collect hot enough to make X-rays in small knots. Their ram pressure begins to matter. Their tides have someone to talk to. In cross-section, the profile from centre outward reads like a musical line, a deep soft note, a gradual swell, a low crest just past the edge, then a return to the mean. Place it beside other voids, and the melody is familiar, only broader and quieter in Boötes, because its edge is shared and its interior is very wide. The quiet mystery keeps its chair how much of the observed outflow at this scale owes purely to gravity's rearrangement of dark matter versus help from baryonic physics feedback that heats and puffs circumgalactic gas, sound waves from weak jets that stir entropy, cosmic rays that cushion filaments, and whether any of these small pressures noticeably alter the void's kinematic profile compared to a dark matter-only expectation. Simulations differ at the margins. Observations lean on statistics. The answer remains a spectrum rather than a point. Dry observations lay 3 flat stones and do not wobble. They call this draining, and in a ledger sense it is yet nothing falls down. Everything simply stops crowding. Leaving is more geometry than gravity's arrow. They call the ridge a ring, and a ring helps a mind picture it. But in practice it is a band broad and modest, more shoulder than wall. They call the outflow fast, and compared to clusters it is yet the numbers remain small in any one galaxy's night tens to a few hundreds of kilometers per second that are felt only in averages and long years. He keeps the imagery elemental so motion can be pictured without push. Imagine a high-pressure system on a weather map. Air glides outward along shallow slopes. At the borders, fronts lift. Clouds line the edges while the centre keeps blue. Nothing is forced, everything prefers. One gentle analogy breathes once and rests. The void is a basin whose water is already shallow. The slightest tilt draws it toward the lip, where it becomes not a waterfall, but a wetting of the shore. He returns it to inhabitants because their lives write the evacuation's calendar in small. A dwarf midway out from centre finds its neighbour list growing thinner with time. Chance passes become rarer. Its neutral hydrogen disk extends farther because no hot medium trims it. As peculiar velocities nudge it outward, the dwarf's path tilts toward a sheet where at last an encounter awaits. Not a cluster's crush, only a modest handshake that stirs a bar and lights a ring. A faint spiral nearer the lip feels the ridge as a mild, persistent gradient. Its outermost gas orbits precess under a pull that is not quite symmetric, and warps show the asymmetry honestly. A small group perched on the bank shows the first signs of environment. A thin, warm intra-group medium. A quenched member or two astream from a minor merger that 1 billion years ago would have had nowhere to fall. The second precise detail fits like a clean label beneath the profile. When many voids are stacked and scaled by their effective radii, their average velocity profiles show outflow in the interior peaking near roughly half a radius, then bending towards zero and slight inflow near, and just beyond the edge, where compensation sits. The Boötes supervoid follows the same grammar, but stretches the distances and softens the crest. He lets growth be seen as merging because in a network voids do not only deepen, they also join. 2 neighbouring basins expand until their saddle thins. Streams that once separated them become corridors. A supervoid inherits both centres and a seam often still marked by a thin tendril of galaxies and gas. The new figure reads as one room with a faint waste. The boat is hollow wears such seams. Their presence explains why some lines from centre to edge climb gently, while others meet a small rise sooner. The lip is higher where two former rims coincide lower where a tunnel opens into a wider bay. In this coalescence, the rate at which matter reaches the nearest wall is set by slopes in the potential. The details of the floor grain from dark matter's small clumps, viscosity from baryons edit but do not rewrite the drift. Three soft ironies take their places. Only took the lowest density to produce the clearest arrows. Only required outflow everywhere in the middle to make the edge the only place where arrival happens. Only needed a ridge born of subtraction, a ring of what left to become the feature observers most easily measure. He keeps dark energy as a background hum because expansion's acceleration changes how rooms age. As scale grows faster, walls do not march inward. They swell in proper distance even as they thicken in contrast. The hollow becomes more itself emptier in relative terms, wider in light years, while correspondence with distant places thins. The evacuation does not rush. It persists. The ridge does not spike. It gentles upward. The web becomes a stronger drawing on a sheet that stretches out under the pencil. He returns to instruments because calm prefers numbers with their units. Peculiar velocity surveys Tully-Fisher distances for spirals, fundamental plane distances for ellipticals extract motions beyond expansion, and in aggregates centered on voids show the outward bias that profiles predict. Redshift space void distortions encode the same bias in shape and fitted with models turn absence into a growth rate constraint. Weak lensing measures the mass deficit and the ridge's low crest. Neutral hydrogen maps draw where cold gas lingers. Ultraviolet absorption towards the background beacons gives temperatures and metallicities for the air the galaxies sail through. Together these instruments agree on the same slow grammar, leaving in the middle, arriving at the rim. The quiet mystery returns with a narrower question. Does the ridge over very long times sharpen into a stronger compensation as basins around Boötes continue to merge? Or will shared boundaries and the acceleration's soft hand keep it broad? Models offer both shapes in different neighbourhoods. The answer here will be in the very outer shelves of future maps, where surface brightness hangs by threads, and lensing shears grow faint, a place instruments have learned to reach only by stacking patience. Dry observations walk their last steps in even shoes. They call the edge where the action is, and it is, but action here is the accumulation of small arrivals, not a battle. They call the centre quiet, and it is though the quiet is the sound of divergence, not of sleep. They call the ridge evidence, and it is while the better evidence is the coherence of many small ledgers agreeing on the same slope. He keeps one human-scale image at the window. If someone stands under a dark sky, in a small spiral halfway out from the void's centre, the dome above looks generous and sparse. The nearest bright galaxy sits as a small knot far to one side. A deep exposure would show the least structure where they stand, and a faint doubling of density toward one horizon, where a sheet lifts. Nothing moves fast to their eye. The motion is in the decades of data a descendant might stack. He lets the section rest where departure and gathering balance into a single profile. Fact in under-dense regions, peculiar velocities point outward. The Boötes interior evacuates while its rim thickens into a modest compensating band, and outflow measured by void galaxy distortions, velocity surveys and weak lensing. Detail outflow peaks inside bends towards zero at the edge, and becomes slight inflow just beyond. Coalesced subvoids leave seams and tunnels that set small variations in the rise. Super Hubble behaviour in the middle, and a broad shared ridge at the lip are both expected for a large composite basin. Mystery the baryonic edit, how feedback cosmic rays and magnetic cushioning adjust the kinematic profile relative to dark matter-only predictions, and whether the compensation here sharpens or stays low as neighbouring basins continue to merge under an accelerating background. Ironies the lowest density draws the straightest arrows. The edge is made by what left, not by what arrived first, and the clearest feature of the void is not inside it, but just beyond. The room continues to empty in the most measured way possible. The shore continues to rise by inches, and the map, which began as dots on paper, now reads as motion away in the centre, along at the rim, and down only where lines converge and give the web a place to thicken. He lets the unseen architecture come forward the way grain appears in wood when light slides across it, because in a hollow, the guidework that remains is not made of lamps, but of gravity. The accepted fact rests in the centre without raising its voice. Dark matter lays the scaffold of the cosmic web, and even inside a supervoid like Boötes, a faint lattice persists, too tenuous to collect many bright galaxies, yet strong enough to steer the few threads of gas and dwarfs that cross the room. He keeps the craft visible, so invisibility is measured and not imagined. Weak gravitational lensing, minute coherent distortions in the shapes of yet more distant galaxies maps projected mass as a low-relief silhouette. Across the Boötes direction, convergence dips below zero in the interior, and rises toward the rim, but it does not fall to nothing. Instead, thin, barely significant ridges line up with the positions of wispy tendrils seen in redshift and neutral hydrogen maps. Simulations built from initial conditions evolved under gravity alone predict precisely this void floors that are not flat but faintly combed by low-density filaments, hairlines of potential, along which matter drifts, and to which the rare residents feel compelled to align. The lesser-known detail takes a quiet seat at the margin, when the shapes of background galaxies are stacked not around the void centre, but along the positions of those interior tendrils. A weak, elongated lensing signal appears subcritical, barely there yet oriented with the threads. In effect, a lensing whisker that says, "A bridge exists where light itself remains reluctant to settle." He lets the scaffold guide the room's small traffic so the few roads have somewhere to go. Along these hairline ridges, neutral hydrogen often extends farther than stars, as if gas explores the path first. Low-mass dwarfs align like beads on string, their velocities are nearly collinear. Star formation flickers in knots where density gathers just enough to tip a threshold. The ridges are not highways, they are cattle trails, routes formed by repetition, not by paving, yet in the arithmetic of emptiness. They are decisive because alternative routes are simply too shallow to keep a flow. The quiet mystery keeps its chair how rough the dark scaffold truly is at the 100 kilo-parsec scale, and below, and how that roughness, clumps too small for stars, waves set by initial noise, translates into the timing and size of the few galaxies that manage to form here. Warm dark matter models would smooth some of this grain. Cold dark matter models keep it crisp. Self-interactions, if present, would change caustics at the thinnest levels. Observations are subtle, their leverage borrowed from stacking, and the ledger remains open by design. Dry observations lay 3 even stones and do not wobble. They call dark matter invisible, and to eyes it is. To geometry it is obvious lensing turns mass into angle. They call tendrils insignificant, yet in a room with little else insignificance becomes governance. Those are the places gas finds and uses. They call void floors empty, but the emptiness is a density contrast, not a prohibition. Potential still has slope, only a gentle one, and gentle slopes still collect what time refuses to hurry. He keeps the imagery elemental so scaffold can be pictured without ornament. Consider winter reeds under a shallow snowfall. The ground looks smooth until wind shifts and low light reveals parallel ribs the snow has settled into. Walk along a rib and your foot sinks less because the grass holds the crust. Leave the rib and the crust fails. The void floor is like that subtle support lines under a blanket of thin air. Galaxies, like careful walkers, prefer the ribs. One gentle analogy breathes once and rests. The scaffold is the faint grain in a slow river's sandbar. Water feels it first, reeds sprout along it. Later the bar looks patterned to anyone who knows where to look. He returns to method because the faintest maps need the steadiest rules. Lensing shapes are stacked after, correcting for point spread functions and detector asymmetries. Sheer 2-point correlations build a model of projected mass. Subtract the contribution from the surrounding walls. What remains is a low contrast relief inside the hollow. Cross-correlation with galaxy position shows that the lensing peaks faint as they trace the same tendrils that redshift surveys plot. Neutral hydrogen surveys at 21 centimeters deeper than the light would seem to invite lay-down contours that stretch along those axes. Ultraviolet absorption toward background quasars adds a tracer for metals, scarce but not absent, saying that some gas has been processed and shared along these lines. The second precise detail pins a small tag to the ledger. The velocity dispersion of dwarfs along a void tendril is anisotropic lower along the filament than perpendicular to it, implying that the potential well of the thread, faint as it is, disciplines motion more effectively along its spine than across its pinnace. The numbers are small, the error's large, but the trend fits a picture in which even a whisper of mass arranges the room. He lets formation and fueling ride the scaffold because in thin places the path matters more than the depot. Inflows along these faint lines are cold by comparison to wall-fed accretion. Shocks are weak. Mixing is slow. The result is that outer disks remain metal poor longer, and that extended ultraviolet rings flare, where gas arrives misaligned and settles into tilted annuli. Warps persist because no one comes to shake them out. Lopsidedness lasts because no crowding rescues symmetry. In one corridor, a pair of low-mass spirals shares a gas bridge. Their star formation rates ripple together in phase as the shared reservoir rises and falls. In another, a dwarf at the elbow of a tendril shows bursty behavior every few 100 million years as clumps slide down and ignite small M faces in an otherwise even sentence. 3 soft ironies find their level. Only took the weakest backbone to keep every surviving rib in place. Only required almost no mass to set nearly all the direction in a room this thin. Only needed the invisible to be barely there for the visible to know where to stand. He keeps the ceiling in view because halos remember scaffold as much as disks do. The circumgalactic medium, thin and warm, hangs from the same faint ridges. Where a tendril crosses cool clumps are slightly more common. Where it does not, the halo is smoother and the cooling time longer. Magnetic fields dragged out by old winds align weakly with the threads and polarized light from the very faint dust that wanders. This far out shows the same lean by a few parts per thousand, small numbers, patient verdicts. Cosmic rays stream along those fields and heat by wave, damping in a way that stretches the last condensing filaments over longer times, a gentle break where gravity would otherwise let gas fall faster. The quiet mystery returns narrower where the self-interacting dark matter would thicken, or thin these corridor cores enough to be seen in future lensing stacks, or whether subhalo counts in gap-riddled stellar streams near the rim will back-illuminate the interior's grain by inference. For now, the inward and the outward ledgers agree on direction and magnitude. Detail waits for the next patience. Dry observations resume their even pace. They call the scaffold theory, but the theory is a simulator's prediction that knows how to be tested. Lensing sees a contour, gas maps see a resonance, star position see compliance. They call the tendrils accidents yet, accidents that repeat across simulation. Surveys and tracers are better named habits. They call the dwarfs flotsam, though most are self-propelled, riding a current that keeps to the same hidden bank. He returns to geometry because even faint structures obey the same rules as the large ones. Tendrils tend to point toward nearby wall junctions. Their cross-sections are elliptical, not round. Their minima and potential are shallow. By any cluster measure tens of kilometers per second squared over megaparsecs. Yet the anisotropy they impose in the local tidal field is enough to talk forming disks into alignments that surveys are just starting to count. Void spin alignments are tentative, but the hint is consistent. Late-type disks in the thinnest places may prefer to spin with axes perpendicular to their host tendril. A quiet echo of the tidal torque theory playing at very small volume fraction. The second lesser detail slips in like a note in the margin halos that host these dwarfs often sport concentration parameters slightly below the median for their mass, a sign that their assembly histories were later and smoother. On the scaffold late comes gently and gentleness leaves a shape. He keeps triangulum out of the room because exterior accents distract from the interior grammar. Here the voices belong to hairline bridges that did not need a third neighbour to exist. What small satellites these dwarfs do have are few and far between. Streams are delicate. Dissolution takes longer. A single star cluster lost to tides can mark a tendril more clearly than a dozen, in a wall precisely because the background is so spare. 3 last soft ironies close their eyes where the light is low. Only took a deficit to trace the most honest lines. Only required a scaffold made of almost nothing to explain almost everything that remains. Only needed a room too large for voices to carry to make geometry the one speaker left. He lets the section settle where mass without light keeps its quiet promise. Fact dark matter provides a faint scaffold through the Boötes supervoid low-density tendrils that lens weakly line up with neutral hydrogen bridges and guide the rare galaxies and their gas. Detail-stacked lensing along interior threads shows elongated whiskers. Velocity dispersions are lower along tendrils than across them. UV rings and persistent warps trace cold misaligned inflow down these spines. Halo concentrations run low as expected for late gentle assembly. Mystery the fine grain of the scaffold, its clumpiness at subgalactic scales, its response to alternative dark matter physics, and the degree to which magnetic fields and cosmic rays modulate gas along it. Irony's the weakest backbone holds the plan. Almost no mass sets the path, and invisibility becomes the most reliable map in a room built from light's refusal to gather. The floor keeps its combed relief. The few roads continue to prefer the same low lines, and the hollow, though defined by the thinning, remains legible because the unseen gives everything that stays a place to stand. He lets the air of the universe step into the light because the Boötes hollow is more atmosphere than architecture. The accepted fact rests quietly in the middle. Most of the baryons in cosmic space are not in stars, but in the intergalactic medium and inside a supervoid. That medium is warm, thin, highly ionized and metal-poor gas at temperatures from tens of thousands to a few million degrees, too diffuse to shine strongly, yet present everywhere as the breath that persists when lights are sparse. He keeps the craft visible so that thinness becomes a measurement. Along sightlines that cross the hollow background, beacons, quasars, bright galaxies, and the rare steady flare of a fast radio burst turn into probes. Hydrogen writes its faintest script in Lyman alpha absorption at low column densities. Oxygen, carbon, and neon add discrete lines in higher ionization states OVI in the ultraviolet, where gas is about a few 100,000 degrees OVI, and OVI in soft X-rays where it is hotter. The forest is not a forest here so much as a copse. Fewer lines, weaker, equivalent widths, larger gaps where no leaf grows. Dispersion, Measures of the fast radio bursts that pierce broad empty corridors run lower than roots that skim walls. Rotation measures are small whispering that magnetic fields twist little in such thin air. The lesser-known detail sits on the sill like a dim candle, the diffuse Haar and Lyman alpha fluorescence of truly empty-seeming space. Recombination light powered only by the metagalactic ultraviolet background is expected at intensities near the patient's limit of cameras. A few instruments claim detections in stacked images along clean void sightlines. A red haze measured in millirayleigh so faint that the night's own air has to be persuaded to subtract itself before the signal agrees to stay. He lets temperature speak in quiet registers because heat here is a context, not a flame. In walls and filaments, shocks from gravitational collapse heat gas efficiently. In voids, expansion stretches parcels and photoheating by the ultraviolet background sets the thermostat. With little compression and few strong shocks, gas inside the Boötes hollow tends to remain cooler than in rims, yet warm enough to ionize hydrogen almost completely. Cooling time lengthened because density is low. Metal lines that would have helped radiate energy away are rare. The result is a medium that changes slowly, a ceiling that stores energy more as posture than as weather. He allows metals to place their small flags. Supernovae in the few resident galaxies seed their halos, and winds carry some of that yield outward. But with few neighbours and little group weather mixing is spare, and profiles of oxygen and carbon fall gently with radius into the thin. Along the faint tendrils that thread the floor, metal lines are slightly more common. The scaffold that guides galaxies also concentrates the crumbs they shed. Elsewhere, void air keeps a near primordial flavour trace seasoning, not broth. The quiet mystery takes its chair without asking for resolution. How much of the warm, hot intergalactic medium in a supervoid sits in smooth sheets at truly low overdensity, and how much hides in tiny clumps, cloudlets, at tens to hundreds of parsecs structured by turbulence and magnetic pressure that boost absorption without much emission. Simulations offer both pictures, depending on resolution and microphysics. Observations taste only what a pencil beam passes through. The ledger remains ambiguous in the way the thinnest soups do, nourishing and transparent at once. Dry observations place 3 flat stones. They call the void interior cold by contrast to nodes, and it is cooler than shocks would make it, yet warm is the honest word photoheated air, whose temperature would boil water and still feels in cosmological terms like a draft. They call it empty, and by column density the emptiness reads yet dispersion measures, and ultraviolet lines insist that emptiness here is a number, not a refusal. They call it quiet, and the quiet is exact, but quiet here means slow, not stillness, only changes that take more time than any single star will recall. He keeps the imagery elemental so thin light can be pictured without embroidery. Think of a high dry sky over a salt flat at dusk. Air holds heat without making weather. Dust motes glow only when the sun is low. The horizon feels far because nothing interrupts it. The Boötes medium is that air only. It is the light that crosses it which tells you the air is there. One gentle analogy breathes once and rests the void's gas is a room's hush between words, present shaping how the next syllable will sound, not speaking itself. He returns to instruments because the faintest ledgers need the most patient hands. The cosmic origin spectrograph passes ultraviolet lines with a view for the lowest columns. Deep X-ray calorimeters accumulate the softest photons to test for OVI and OVAI. Radio arrays catch transient fast radio bursts and add their dispersion to the map. Stacking microwave maps on many voids finds the slightest integrated Sachs-Wolf imprint. Gravitational redshift from evolving potentials that, while debated, aligns with the idea that emptier rooms do slightly different work to passing light. Cross-correlate all of these along the same sightlines and a consistent picture resolves thin, warm, highly ionized gas, low metals, small fields, long cooling times, and a total baryon fraction that helps close the budget of what the universe has and where it keeps it. The second precise detail sets its label where numbers agree to gather electron densities in the deeper interior are so low that recombination times stretch to giga-years. Once ionized hydrogen stays that way unless the ultraviolet background dims by orders of magnitude. The medium is in that sense chemically and thermally inertial, a property that makes Void's clean laboratories for any slow drift in the background's power. He lets motion enter again because even thin gas has currents. Within the hollow, peculiar velocities move air outward with the galaxies very slowly, very steadily. Along a tendril flows slides toward walls with enough coherence that a background quasar sees slightly higher column when the beam grazes a thread and slightly less when it walks the broad floor. Turbulent velocities are small compared to rims. Line widths lean more thermal than kinematic. In the ledger, the sky looks like a place where the wind would rather whisper than gust. 3 soft ironies find their level. Only took the faintest lines to count most of the matter that light ignores. Only required the thinnest air to preserve the longest memory of heating and ionization, because nothing intervenes to erase it. Only needed a room nearly without weather to make the study of climate possible, background light and slow expansion writing the temperature more than local storms. He keeps magnetic fields and cosmic rays in the margin because even a whisper has structure. Rotation measures toward the background sources in void directions are near zero, but not precisely so. A few nano-Gauss fields ordered on a megaparsec scales by flows along the scaffold can account for the residuals. Those fields guide cosmic rays which stream and heat by damping alpha-n waves. The rate is small but not trivial when densities are so low. In stacks, such heating stretches the last condensing threads, turning what might have been quick drops into long drizzles. Whether this edit matters for the handful of galaxies that live here is a measurement still gathering courage. He returns to light that is not from lines because continua carry hints too. The extragalactic background light, integrated starlight and dust processed glow passes untroubled through the hollow. Gamma rays from far beacons when they exist pair produce on that background and spawn electron-positron cascades that in principle could seed a low-level glow, but numbers fall below thresholds. The more practical continuum is the microwave background's slight dimples where voids shift photons' energies by evolving their shallow wells. In Boötes, one well among millions, the imprint is a syllable in a chorus. The meaning lies in harmony, not in solo. Dry observations resume their even pace. They call the gas WIM, and the acronym Warm-Hot Intergalactic Medium does the job. It is both warm and hot, and its most important property here is neither it is thin. They call metals pollution, which implies corruption. In practice, metals are tracers of reach, how far a few explosions can write into quiet air. They call detection marginal, and along single sightlines it is. Stack enough and margin becomes shape. He keeps one human-powered image where the window meets the night. Imagine a world in a small spiral near the floor of the hollow. Nothing in the sky tells the eye that the air between galaxies is warm. Telescopes feed their prisms and gratings and find the faint teeth of oxygen and hydrogen. Scientists write the numbers in a ledger and say the room has this much breath at this temperature with this few traces of older fires. The night feels no different. The mind rests more easily because the silence is now measured. He lets the section settle where the ceiling and the floor agree to be the same substance. Fact inside the Boötes supervoid, the intergalactic medium is warm thin, highly ionized and lightly enriched, seen in weak Lyman alpha and metal line absorption, hardly seen in emission, and confirmed by small dispersion and rotation measures, and by the faintest statistical imprints on microwaves and shear. Detail fluorescence from the ultraviolet background sits at the edge of detectability. Recombination times stretch to giga years. Metals and magnetic fields concentrate slightly along interior tendrils. Fast radio burst sightlines through emptiness return lower dispersion and nearly null Faraday twists. Mystery whether the gas is mostly smooth or mostly clumped at tiny scales. How much cosmic rays and nanogauss fields lengthen. Cooling and delay condensation, and how a slow background that changes with epoch imprints itself on such a patient medium. Ironies. The weakest lines count the most mass. The thinnest air remembers heating longest, and a place with almost no weather becomes the best climate record in sight. The room keeps its temperature, the breath keeps its pace, and the hollow, which looks like nothing, remains a sky full of numbers that only the most careful knights bother to collect. He lets growth be the slow act of subtraction, because in a hollow, becoming larger means letting go. The accepted fact rests in the middle without raising its voice. Voids expand and merge as the universe evolves under dents. Regions grow emptier and broader. Neighbouring basins touch at saddles and coalesce, and the composite that remains inherits a deeper interior and a gentler, wider rim. This void-in-void process is the natural complement to how clusters assemble at nodes. He keeps the craft visible so that expansion is more ledger than metaphor. Write the density contrast as Dazer and follow it with time. In linear theory, an initial negative "the" becomes more negative as the growth factor rises. In the non-linear script, out flows from many small hollows lower the floor further while feeding the sheets between them. When two basins' boundaries thin to nearly nothing, their flow lines connect and the pass becomes a tunnel. The new room keeps both centres and a seam that fades by mixing rather than by decree. The lesser-known detail sits quietly near the lip. Compensation around large voids and overdent shoulder just beyond the nominal edge changes with maturity. Young voids still confined by stronger surroundings show sharper higher shoulders. Older merged supervoids like Boötes share boundaries with many neighbours and collect less tightly, leaving compensation low and broad, more swell than ring. He lets time add layers the way wind adds dunes. At high redshift, many small hollows stipple the map. By intermediate epochs, those hollows have begun to join into a hierarchy subvoids nested within larger basins. By the present, the hierarchy has thinned to a few wide rooms stitched from many. The centre's deficit deepens while the outer slopes soften. Inside tendrils of dark matter left from earlier seams survive long enough to guide the few inhabitants. Outside sheets thicken modestly where drainage converges. In cross-section, the profile that started as two adjacent dips separated by a shallow saddle becomes one long bowl with a faint waist. Rotate the plane and the waist moves the signature of a merger that never needed ceremony to be complete. The quiet mystery keeps its chair how percolation proceeds when basins are this large. At what thresholds voids stop being individual rooms and begin to form a connected, underdense network that spans survey volumes. Simulations find transition points where emptiness links up the way water finds a continuous channel in a landscape. Observations must infer them through algorithms and limited depth. Boötes sits near such thresholds big enough to tempt percolation irregular enough to resist a single description. Dry observations place 3 flat stones. They call merging collapse in reverse, which helps a mind, yet nothing collapses here. Everything separates in a way that makes shape sharper. They call the result one void, and statistically that is useful. Dynamically it is a family album with the faces blended. They call the pace slow, which it is for humans. For the map, slow is the only speed that writes a faithful line. He keeps the imagery elemental, so coalescence can be pictured without drama. Think of two shallow lakes whose shorelines creep outward in spring. At first, a thin ribbon of damp ground separates them, then a channel opens. Soon you cannot tell where one lake ends and the other begins, except for a faint bar of sand under the water that later shifts and fades. The supervoid is the conjoined lake, the sandbar is the seam. Wind and small waves rearrange nothing quickly, and yet the shoreline changes. One gentle analogy breathes once and rests the void. Hierarchy is like a set of nested bowls filled with fog. The smallest bowls lose their fog to the larger and the largest to the room. What remains is one basin with eddies that remember older rims for a while. He returns to the arithmetic of hierarchy because calm enjoys simple rules. In excursion set language, one draws a random walk of density smoothed on different scales, and asks whether the walk crosses a negative barrier that signifies a void. Multiple crossings encode nesting, small crossing inside larger ones. As time passes, the barrier effectively lowers for under densities and small voids embedded in walls. The void in cloud case are crushed as their surroundings collapse, while small voids inside larger ones, the void in void case, survive and merge upward. Boötes is the end of many such survivals. Its present softness at the edge is a signature that its mergers were mostly of the void in void kind. The second precise detail sets its tag where numbers prefer it stacked. Radial profiles of identified voids when binned by size show that larger radii correlate with lower central density contrasts but broader edges. The derivative of density with radius, how fast the profile climbs, falls for the largest merged systems. In Boötes, this derivative is small over a long interval, a shape one expects when many subvoids have already surrendered their rims to the common bowl. He lets motion keep the narrative honest. Where basins join the velocity field rearranges. Streamlines that once converged on a saddle now course along a single wider route toward a shared rim. Peculiar velocities in the new middle align more coherently outward. The old edge's slight inflow just beyond the former boundary weakens. The compensation's crest, where it exists at all, drifts farther from the centre. Galaxies that lived near the old pass now sit in a tunnel, kinematics along its axis slightly colder than across. Gas that had once accumulated at two separate lips chooses one and the other decays into a gentle slope. Three soft ironies find their level and stay. Only took separations everywhere to knit a single room. Only required fewer boundaries to leave more structure. The thin threads that remain stand out better against a wider floor. Only needed slow, steady outflow to create a shape most easily drawn by its lack of change. He keeps inhabitants in view because coalescence edits their weather. When two basins marry, the interior becomes more uniform and more isolated. Chains of dwarfs that once fed from two funnels find one. The cadence of minor accretion never busy becomes steadier. Outer disks in small spirals warp a little less because the asymmetries that used to tug from two sides now resolve to one. Near the rim, the opposite passages become very slightly more common. Groups inherit one more small stream from the merged side. A few histories at the edge gain punctuation marks they would not have had if the seam had stayed a wall. The lesser poetic detail sets itself on the sill in deep imaging around the shared lip. A faint scalloped pattern of intra-group light often betrays where returning debris from small late mergers piles along orbits that have lengthened shells in profile, that by spacing quietly clock time since the pass opened. He returns to redshift because the room's age can be read as a scroll. At earlier cosmic times, the void function number of voids at a given radius tilts towards smaller sizes. At later times, the curve leans to larger. Translate to Boötes, and the message is simple: what is broad now was many in the past. If one could slice the same region at redshift 1, the bowl would be shallower, its seams sharper, its compensation heiser, By redshift 0, the bowl has deepened. Seams have blurred and the rim has shared its crest. The quiet mystery keeps its measure. Whether acceleration, the late dominance of dark energy, freezes the last steps of percolation here, leaving Boötes near its present breadth indefinitely, or whether residual merging among neighbouring basins continues slowly lifting one lip and lowering another, so the bowl becomes still wider and even less defined at the edge. The balance between growing isolation and local rearrangement will decide how many more seams can dissolve. Dry observations resume their even pace. They call the process self-similar, and in a stacked sense it is. Yet each specimen, especially a large one, keeps a signature of how and where it merged, wastes, tunnels and slight axis preferences. They call the profile universal, which is useful. Boötes is faithful to the grammar but speaks in long vowels. They call the timeline inevitable, which it is for underdensities, while the precise path, how many subvoids which saddles opened, first remains a history. Nothing else will ever repeat exactly. He keeps method close because hierarchy is recovered, not declared. Watershed algorithms identify basins at multiple smoothing scales and trace their genealogies. Merger trees for voids analogous to those for halos record which small rooms joined and when. Cross-checks with lensing and velocity reconstructions test whether the derived seams match real corridors. In the Boötes direction, the family tree prefers breadth over depth, several mid-sized hollows joined rather than a tower of many small ones nested. The result is a composite that feels even and large rather than terraced. The second lesser detail sits down with a modest grin redshift space void shapes, slightly elongated along the line of sight in young, fast outflowing basins tend toward rounder projections after mergers because averaging across many former centres washes out anisotropy. Corrected for distortions, Boötes still keeps its gentle ellipsoid, yet its redshift footprint looks smoother than the sum of its parts. He keeps a human-sized image at the window so scale stays honest. Imagine standing in a small spiral that once lay near the seam of two ancestral hollows. In the deep past, the nearest bright horizon appeared in two directions, two banks of slightly higher density. Tonight one bank remains a bit higher, the other is a low rise. The sky looks scarcely different to the eye, but the map beneath agrees that one channel won the other, became a shallow bay. Three last soft ironies rest where the light is low. Only took time to turn many emptinesses into one that feels more itself. Only required merging to erase edges and yet make the interior more legible. Only needed the thinnest traffic to produce the cleanest long-term record of flow. He lets the section settle where hierarchy has become posture. Fact voids grow and merge. Boötes is a supervoid assembled from smaller basins whose seams survive as faint tendrils, while the interior deepens and the edge broadens. Compensation lessens and spreads with maturity. Detail excursion set language encodes the hierarchy. Stacked profiles show lower slopes for larger voids. Velocity fields realign as saddles open. Redshift space shapes smooth after coalescence, even as real space ellipsoids persist. Mystery percolation thresholds and late-time freezing under acceleration. How completely Boötes links to neighbouring hollows, and how many seams can still dissolve. Irony's separations knit a single room. Fewer boundaries leave more trace. The slowest flows write the clearest map. The bowl keeps widening by inches, the rim shares its rise, and the great hollow built by subtraction continues to become more itself by continuing to become less. He lets motion narrow into guidance because near a void's rim direction becomes a habit more than a choice. The accepted fact rests in the middle without raising its voice. Galaxies and gas, inside and under density, drift outward and then near the boundary. their paths tilt and slide along. Sheets' flows turn from radial to tangential, guided by the shallow slopes of the wall and then down the spines of filaments towards small nodes. He keeps the craft visible so the rim is a kinematic place, not just a line on a map. Peculiar velocities that point nearly straight outward at mid-radius gradually acquire shear. The velocity divergence fades to zero while the shear grows. Streamlines bend into the plane of the sheet and then trace the filament's axis. In the Boötes hollow, this change is not abrupt. The gradient stretches across tens of megaparsecs. The result is a broad colonnade where orbits elongate and align. The lesser-known detail sits like a faint inscription along that colonnade-stacked void galaxy. Correlation maps in redshift space show a narrowing of the contour lines near the rim, the so-called Kaiser squashing from coherent infall towards sheets mixed with outflow from the interior, subtle here, but persistent. When corrected for distortions, the same galaxies reveal a mild anisotropy in their shapes and spins their disks, tending to align with the sheet's plane, and their minor axes avoiding the filament's core by a small measurable margin. He lets the floor's last relief feed the wall because guidance requires a slope. Along corridors where two basins once met the pass that became a tunnel, now feeds a particular segment of the rim. Gas in the intergalactic medium arrives a touch cooler, their metals a bit scarcer, and the sheet receives a stream that is less shocked than its other supplies. The result is a rim with districts patches where star-forming spirals keep larger HI reservoirs than neighbours at the same radius groups where intra-group gas is warmer because supply lines are richer, and lanes where dwarf chains still carry the cadence of their interior tendril. He keeps gas and stars on the same ledger so the shift in direction reads in both. Neutral hydrogen disks at the brink show asymmetric warps that point on average toward the sheet's midplane. Molecular gas fractions begin to rise compared to the floor, yet remain below cluster values. Star formation surface densities climb modestly as tides and low ram pressure finally have partners. In ultraviolet extended rings at the very edge, common inside give way to more continuous rims of knots. In Ha, the bubbles are still individual rather than confluent. The wall is an introduction to conversation, not a crowd. The quiet mystery keeps its chair how much of the rim's kinematic guidance is set by the dark scaffold alone, and how much is reshaped by baryonic weather feedback that stirs the sheet and sets local pressure magnetic fields that thread along filaments, and prefer certain inflow angles and cosmic rays that leak from wall galaxies and slow the last cooling clouds. Simulations differ at the few tens of kiloparsec scale. Measurements lean on stacks and careful control samples. The exact partition remains an honest uncertainty that matters most where guidance is faintest. Dry observations set 3 even stones. They call the rim infall, and the word works in profiles, yet most paths are glides along planes, not plunges. They call the sheet dense, and by void standards it is. By cluster standards it is still open country, the physics is encouragement, not enforcement. They call the kinematic signature small, and it is small per object. In aggregate it is the clearest handwriting the rim owns. He keeps the imagery elemental so the turn in motion can be pictured without spectacle. Think of wind crossing a prairie into the foothills far from the ridge. It flows outward evenly. Near the slope it veers and runs along the contour. Only at gullies does it drop decisively toward the valley. The void's rim is those first hills. Filaments are the gullies, nodes are the valleys. Most air learns to follow the lay rather than rush the fall. One gentle analogy breathes once and rests the shift from radial to tangential near the rim is like reaching the shore in a kayak. The last meters of approach are not straight in, but angled with the longshore current until a channel opens. He returns to measures that catch guidance in numbers rather than drawings. In redshift space, the two-dimensional correlation between void centers and galaxies shows rounder contours inside flattened ones near and just outside the nominal edge. Model fits return a coherent outflow inside a side slip at the boundary and a mild net inflow in the compensated band. In real space reconstructed from peculiar velocity catalogues, the shear tensor rotates its principal axis. A positive eigenvalue along the inward normal gives way to smaller values in the plane. The vorticity negligible in the floor grows gently along filaments where flows curl around the spine. Weak lensing stacked tangentially around identified sheets reveals a low but finite surface mass density that explains the guidance. HI interferometry across select rims catches the warps that betray the plane's pull. The second precise detail pins a small tag to the ridge satellite systems around modest groups perched on the Boötes rim show anisotropy. Their satellites align preferentially along the local filament axis and their orbits tilt more in the sheet than out of it. Splashback radii, where satellites reach first apocenter around the host, appear slightly elongated. Along the filament, a quiet echo of the same guidance written into still-bound structures. He lets pre-processing at the wall keep its own mood because edges change cadence before interiors. Dwarfs that approach along a filament meet the sheet's mild tides and thin intragroup media. Their HI disks begin to truncate at the far edge, not because of a hot sea, but because repeated weak tides and drifts along the plane stir asymmetric torques. Bars that were slow inside grow stricter. Star formation shows a first episode of compactness in the inner kiloparsec. Quenched dwarfs remain rare, but their fraction rises from almost none to a few percent. This is not yet the grammar of clusters, only the first lessons in that language. 3 soft ironies find their level. Only took a turn in direction to change how galaxies breathe. No crash, just a sidewind that tightens lungs. Only required a sheet thin by any cluster measure to teach disks new habits: slightly higher pressure, slightly quicker bars, slightly shorter fences around gas. Only needed the weakest tides to leave the most legible signatures here, precisely because nothing louder speaks. He keeps the intergalactic medium in sight because the air's guidance is the star's context. At the rim, the warm hot gas thickens. Oxygen lines grow more frequent and stronger. Temperatures rise into parts per million Kelvin. Turbulent line widths increase. Rotation measures toward background sources lift slightly as magnetic fields strengthen with density. Yet the field still looks like a dawn sky. Few clouds more gradation than structure. Along a filament, cool clumps descend shredded modestly by Kelvin Helmholtz drags that remain gentle. Conduction and cosmic ray heating stretch their fall into long streaks. When those clumps meet a halo, they settle more efficiently than floorborne drips because alignment makes less work. The quiet mystery returns by the door. It prefers whether guidance near the rim sets a timescale for disk thickening and star formation compaction that is universal across large voids, or whether each supervoid's seam history, where tunnels meet lips, imprints a local schedule. Boötes stitched from several basins offers districts. Other hollows with one dominant pass may shape a cleaner, sharper shelf in the same metrics. Dry observations resume their even pace. They call guidance flow, though in instruments it is really statistics ellipses, in correlation maps, shears in tensors, low contrasts in lensing. They call alignment weak, and it is within any one wall. Across many the weakness becomes a rule. They call the rim where structure begins, which flatters the inside. Truth is gentler, structure persists everywhere. The rim simply adds a direction the floor did not require. He returns to people-sized night so scale keeps its honesty. Stand in a small spiral parked just inside the Boötes lip. The starfield looks like any quiet disk. Faint smudges of neighbours line one horizon more than others. A long exposure suggests a subtle difference in warp between the inward and along wall sides. Radio maps would show the asymmetry more easily than eyes. Patient spectroscopy would find the disk's rotation bending to the plane's pull by a few kilometres per second. Nothing dramatic attends the turn, and yet the ledger records that a life spent near a wall has a different posture than a life lived on the floor. The second lesser detail settles by the window planetary nebulae, and globular clusters in groups on the rim trace anisotropic orbits flattened in the sheet, stretched along the filament, so even the tracers of old stars rehearse the same guidance. Stacks of their velocities give the wall a kinematic fingerprint that outlives the last gas accretion event. 3 last soft ironies rest where the light is low. Only took a sideways drift to show gravity's handwriting more clearly than any crash could do. Only required the quietest bend in a streamline to bend the lifetime of a disk. Only needed a place still called empty by many to carry the most delicate signatures of direction. He lets the section settle where flows turn into lanes and lanes into habits. Fact near the Boötes rim, outward motions from the interior rotate into shear along sheets and then into guided streams down filaments. Maps in redshift space peculiar velocity reconstructions, lensing, stacks, and HI kinematics all register the same choreography. Detail void galaxy correlations flatten at the edge, galaxy shapes and spins align weakly with sheets, satellite systems elongate along local filaments. Warps and molecular fractions shift first at the brink. Planetary nebula and globulars in rim groups inherit the same anisotropy, mystery. The balance between dark scaffold and baryonic weather in setting guidance, and whether each supervoid seam history writes a distinct schedule for disk thickening and compaction at its walls. Irony's a turn, not a fall, changes futures. The thinnest tides write the clearest notes here. And the place many call the end of structure is precisely where direction becomes easiest to prove. The rim keeps its plane, the filaments keep their axis, and the hollow, generous with distance even at its borders, continues to teach that motion's quietest lesson is not speed, but orientation. He lets rotation become a kind of weather, because in a hollow, the most faithful inheritance a galaxy carries is how it turns. The accepted fact rests quietly in the middle. Void. Galaxies tend toward higher specific angular momentum for their mass later morphologies and gently rising rotation curves. They form stars at low but steady surface densities and keep extended low shear disks, where gas survives farther out than in busier places. He keeps the craft visible, so spin is measurement and not metaphor. Specific angular momentum J-scales with mass in a loose power law. For small spirals and dwarfs in underdense regions, the constant sits higher, more spin per star. Rotation curves read in neutral hydrogen lift softly, and hold a plateau that is lower than in bright spirals but more extended in radius. Dispersions are low, asymmetric drift, is modest. Warps are common and mild. Star formation traces a flocculent script localized buoy regions along filamentary arms that rarely meet to shout. The lesser-known detail settles along the outer rim of these disks in many void spirals. The outermost star-forming knots coincide with changes in the orientation of the kinematic major axis. The line of nodes twists by a few degrees where misaligned inflow lands and ultraviolet clumps ride those twisted and newly in effect a weak kinematic spiral written not by tides but by the slow addition of gas with just different angular momentum. He lets tidal torque theory speak softly because origin matters even when life is quiet. Before collapse, protohalos acquire spin from the tidal field of surrounding mass. In sparse regions, that field is weaker and more coherent, so the net torque integrates longer with fewer interruptions. Later, absent violent mergers, that early spin experiences fewer resets. The result is a higher J at fixed mass and a cleaner mapping from halo spin to disk size and thickness. In the ledger, that mapping shows up as large HI to stellar size ratios, extended ultraviolet rings, and low central surface brightness compared to the same mass near a wall. Star formation is then written by thresholds where gas surface density exceeds a few solar masses per square parsec, and shear is not too strong. OB associations kindle. Elsewhere, the disk stays dark but remains available, a pantry rather than a song. The quiet mystery keeps its chair without asking for an answer. How much of the higher J in void galaxies is set by that early tidal origin, and how much by later cold misaligned accretion that adds spin faster than stellar mass? Whether cosmic rays and tangled but weak magnetic fields preserve thinness by cushioning turbulence, and whether small satellites along interior tendrils add angular momentum by gentle prograde drips rather than by the rough punctuation of mergers. Simulations draw versions of each path. Instruments see the outcomes thin flared extended disks. The balance remains a distribution, not a verdict. Dry observations lay three-level stones. They call these disks fragile, and kinematically they are low dispersion, easy to warp, yet fragility. Here is persistence, nothing leans on them, so they last. They call the star formation anemic, and by surface density it is. By duty cycle it is faithful long runs at low flame. They call the rotation slow, and by peak speed it can be. By radius it is generous. What is slow lasts longer and reaches farther. He keeps the imagery elemental, so spin can be pictured without rhetoric. A void spiral is a shallow river with a broad bend. Water moves, rarely breaks. Reeds grow along the outer bank. Silt lays down in quiet spirals. Now and then a new trickle joins from a side channel and tilts the bend by a degree or two. No floodplain stories, only the long curve continuing. One gentle analogy breathes once and rests the disc, is a long-playing record turned at a soft speed. Dust on the edge makes a faint new track, and the needle follows without hurry. He returns to alignments because the web's grain whispers even in thin rooms. Spins of lake-type galaxies in sparse environments show hints of correlation with local structure disk axes, preferring to sit perpendicular to interior tendrils and lying within sheets near the rim. The signals are weak in any one district and grow only in stacks. Still, they fit a story in which angular momentum is not random, but borrowed from large scales, first by tidal torques in the linear era, later by the direction of cold supply along the faint dark ribs that cross the floor. Inside Boötes, where those ribs exist as whiskers more than beams, the alignment reads as a bias rather than a law, a nudge that a long ledger can see and a single sky cannot. The second precise detail places itself at the disk's reflective inner lane, where bars do appear in void spirals. Their pattern speeds are often low and their growth slow. Corrotation lies far out. Rings at resonances inner and outer are present but not strongly fed. The absence of frequent interactions leaves bars to proceed by internal instabilities, and the time scale for inflow and central concentration stretches accordingly. In spectra, this shows as weak central bursts, low ionization lines from a handful of shocks and old light dominating the inner kiloparsec, sooner than in walls where bars are kicked and refueled. He lets chemistry echo the kinematics without taking the stage. Metallicity at fixed mass leans low. The mass-metallicity relation shifts downward by a few tenths of a dex, with scatter that tracks gas fraction. Gradients are shallow, controlled by long mixing lengths and cold inflow at large radii. Azimuthal variations grow and linger because shear is mild and replenishment is misaligned in places. Where a dwarf along an interior tendril falls in on a prograde path and is absorbed without strong tides, The outer metallicity jumps at a radius matching the last loops of the donor's orbit. Beyond ultraviolet knots, trace the new supply. Inside the old gradient glides on. 3 soft ironies find their level. Only took the lowest noise in the universe to preserve the clearest note of rotation. Only required star formation to be least fervent for disks to live longest and look largest. Only needed fewer neighbours for alignment with the web to become easier to hear. He keeps the circumgalactic medium close because the ceiling sets the turntable's friction. Around a void spiral, the halo is warm, low entropy and low pressure. Cooling is slow but constant. Clumps condense along field lines and stream in on paths set by the faint scaffold. Angular momentum is added at radii, where the halo and disk exchange most easily, often beyond the optical edge. Misalignment is common enough that outer planes tilt. Lopsidedness persists for giga-years. Kinetic energy in warps is shed slowly by dynamical friction in a halo that is itself lightly stirred. Cosmic rays stream outward and heat by the wave, damping at rates that are small per cubic centimetre and decisive over long spans. The effect is to spread accretion over time and radius, keeping new gas from crashing and instead inviting it to file in and take a seat. The quiet mystery nudges a narrower question, whether the stellar initial mass function in these low-pressure, low-metallicity outskirts shifts in subtle ways, slightly top lighter perhaps, or simply more stochastic, altering ultraviolet to Haar ratios used to measure star formation. Some studies suggest deficits in nebula lines for the same ultraviolet dust-corrected light, as if sparse sampling of massive stars in low-density regions skews the tracer. If true, the already low rates in void rims are even quieter than they look. The ledger waits for more patient nights. Dry observations resume their unhurried walk. They call giant low-surface brightness galaxies failed, and some are relics of high spin with little central growth. In voids, they are less a failure than a policy, keep J-spend slowly. They call dwarfs bursty, which is often correct. In these rooms, the bursts are mild emphases on a steady tone rather than punctuation marks that change the sentence. They call extended disks diffuse, and diffuse is a lens setting. In dynamics, it is leverage, mass. Further out stabilizes the middle and feeds a future at the edge. He returns to numbers because calm likes a scale. A typical void dwarf rotates at tens of kilometers per second, not hundreds. Its HI disk runs to several optical scale lengths. Its specific star formation rate rests in the main sequence for its mass or slightly above, not by vigor but by persistence. Its J-M sits above the median and lines up with late assembly. A modest void spiral doubles its stellar mass in many Hubble times, occurred at the present rate, a phrase that says, sleep more than sprint. Yet the same spiral can keep a blue rim alive as long as supply continues to arrive in rings the eye will never see and the ultraviolet camera will always find. One more precise detail takes its seat without flourish: outer disk stability. Measured by the Tumra Q parameter, often balances near unity when azimuthally averaged, stable in patches, unstable in knots, precisely the regime where flocculent structure perpetuates itself without external triggers. The result is an evergreen of small associations rather than a forest of giant complexes. He keeps the human scale window open so the posture remains clear. Under such a sky, constellations in the disk stand widely. The Milky Way's showy lane is absent. A telescope gathers hydrogen's whisper for hours and draws a circle larger than the stars have led the eye to expect. The rotation curve rises, and then instead of leaping strolls. A spectrograph maps a twist in the line of nodes by a few degrees. An ultraviolet image writes a ring where the optical frame insists on emptiness. The night feels honest. Motion is not a spectacle but a habit. Colour is not a verdict but a pace. 3 last soft ironies lie down where the light is low. only took almost no meddling to let angular momentum keep its promise, only required the faintest inflow to keep the most extended disks alive, only needed the smallest star-forming knots to reveal the most decisive geometry, how gas arrives where it settles, which way the record spins. He leaves the section where rotation has become the grammar of quiet. Fact-void galaxies carry higher, specific angular momentum for their mass rise to gentle rotation curves and form stars steadily, at low surface densities across extended low shear disks, fed by misaligned cold inflow. Detail line of nodes twists mark outer accretion. Bars grow slowly with low pattern speeds. Metallicities sit low with shallow gradients. Tumora Q hovers near unity and outskirts. Alignments with faint interior tendrils appear in stacks. Mystery. The partition between primordial tidal torques and late misaligned accretion in setting the high J. The role of cosmic rays and weak fields in preserving thinness, and whether tracer systematics hide even quieter star formation at the edge. Irony's fragility becomes longevity. Low rates make large radii. The least nudge spins tell the clearest story about how the web gives disks their turn. The record keeps playing. The needle drifts outward by millimeters over ages. The song is the same and always new where the edge takes on a little more sky. He lets counting turn into cartography because in a hollow the truest picture arrives as arithmetic arranged in space. The accepted fact rests quietly in the middle emptiness is measured with redshift spectra that turn angles into distances, then shaped by algorithms that find basins in the galaxy distribution and report profile sizes and centers with errors that are patient and small. He keeps the craft visible so maps of a lack become method rather than mood. A flux-limited survey begins by pointing at smudges and turning their light into wavelengths. Emission and absorption lines slide redward, and the shift gives recession. With a cosmological model, velocities become comoving radii. The sky's two angles and one distance build a cone of dots, first sparse then dense as instruments improve. From that cone, a density field is persuaded into being tessellations parcel space into cells around each galaxy. A reconstructed field smoothed on chosen scales tamps shot noise. Masks and completeness are divided out. Selection functions weigh each dot. Only then do automated eyes look for basins. The lesser-known detail sits with neat humility near the margin fibers on multiplex spectrographs cannot always both land on very close targets, leaving unobserved pairs that create tiny holes in catalogues. If uncorrected, those holes mimic thinness and generate artificial subvoids. Tiling strategies and angular upweighting repair most of it. But the lesson persists before emptiness can be trusted. The instrument's geometry must be subtracted as faithfully as the night sky. He lets the catalogue become a landscape by the quiet logic of watershed. Treat the smoothed density like elevation. Let virtual water fill the lowest zones. Where lakes touch at saddles, draw a ridge. The catchments are voids, their lines are rims, their deepest pixels are centres. Other finders use spherical underdensity thresholds or Voronoi cells to assign volumes. None is uniquely right. All, when calibrated on simulations, agree on the big basins and differ in the lace. Applied along Boötes, they recover the same broad room lumpy and layered. Effective radii appear by equating volumes to spheres. Stacked profiles of many voids show the same grammar, deep center slow rise. Modest compensation just outside the nominal edge, while the specimen itself keeps its long vowels. He lets redshift space be corrected by its own signature, so that shape does not lie. Peculiar velocities stretch clusters into fingers along the line of sight and by symmetry tend to make voids look slightly elongated or squashed depending on scale and model. Model, the anisotropy of the void galaxy correlation function fit for coherent outflow and for geometric dilation, and recover both the growth rate of structure and a distance ratio. In stacks, the same trick becomes a cosmological yardstick, the Alcock-Paksinski test on hollows, asking whether average voids look statistically round in the correct cosmology. If not, line of sight and transverse distances are mismatched and the model is nudged. Boötes, when placed inside these stacks, is one contributor among many. Its particular lopsidedness gets smoothed, its existence strengthens a profile, and the larger room yields a number that does not raise its voice. The quiet mystery keeps its chair without pressing for a verdict, whether increasingly deep photometric surveys where redshifts are estimated from colours rather than measured from lines can recover voids cleanly enough to rival spectroscopic maps for profiles and for the geometric test. Photometric errors blur the line of sight and make basins look fatter. Machine learning and cross-correlation sharpen them back, but the resulting void catalogues still carry different systematics. The ledger is improving, not finished. Dry observations lay 3 even stones. They call wedge plots pictures, though the pictures are weighted counts behind masks, not skies. Seeing is a learned operation. They call the edge an edge, while every algorithm that finds it defines it differently. Comparisons level the differences by stacking, not by decree. They call emptiness found, yet what is found is a minimum in a smoothed, corrected field whose truth depends on patience with bias and completeness. The emptiness remains physical because every alternative ledger lensing gas velocity keeps pointing to the same room. He keeps the imagery elemental so measurement can be pictured without glare. Think of tracing a dry lake with stakes in the ground. Each stake marks where water once stood. Join the stakes and the shore appears. Smooth the line and you get a curve. Leave it jagged and you get a history of gusts. The redshift catalogue is a field of stakes. The void outline is the curve. The choice of smoothing decides whether you publish a coastline or a weather report. One gentle analogy breathes once and rests. The algorithms are patient carpenters planing a rough board. The grain always existed. The tool chooses how much to reveal. He returns to cross-checks because the faintest maps deserve more than one witness. Weak lensing stacks pixels of shear around identified void centers and find broad negative convergence less mass than average, rising toward a low crest beyond the edge. CMB maps stacked on supervoids search for the integrated Sachs-Wolf whisper photons losing and then not fully regaining energy as they cross evolving shallow wells, small arguable in single cases, but real in ensembles. Fast radio bursts add dispersion measures. Sightlines that cross clean floors return lower electron columns than routes that skate rims. Ultraviolet spectra toward background beacons find fewer and weaker metal lines in the middle, and slightly more along the interior tendrils matching the faint scaffold redshift maps suggest. Each witness offers little alone. Together they compose a monotone that is enough. The second precise detail sets a careful label at the rim splashback in halos, where satellites complete first orbits and pile into a steepening of number density has an analogue in void stacks just beyond the nominal edge where compensation peaks. The location of that crest in scaled units is a low variance statistic, and its weak evolution with redshift encodes how fast basins deepen. In Boötes, the crest is broad and low, as expected for a merged older room. He lets error budgets walk beside the map so that confidence is not mistaken for certainty. Malmquist bias favours bright galaxies far away. Corrections shift colours into different hands. Survey masks hide low-latitude patches and create artificial bays. Integral constraints move the zero of density. Jackknife resampling and mocks raised from n-body boxes estimate covariances. Likelihoods are reported with errors that look calm because they were earned. Even the choice of center matters: density minima, volume-weighted barycenters, or potential minima do not coincide perfectly. Profiles vary slightly with the definition. The large picture refuses to shift. 3 soft ironies find their level. Only took measuring where things are to prove where things are not. Only required subtracting the instrument more carefully than the sky to publish a map of what the sky lacks. Only needed stacking many rooms to take a yardstick from hollows, while single specimens, those we name, insist on keeping their character. He keeps Boötes present without making it singular. In its direction, survey footprints have gaps and overlaps. Fiber tiling leaves shallow footprints repaired in pipeline. Selections grow stricter with moving distance. Still independent campaigns and later deeper passes draw the same cavity. Rotation of wedge diagrams shows a bay that refuses to fill no matter the angle. Alternate void finders report overlapping basins with different surnames and the same address. The lumpy floor appears where tessellations assign large cells. The thin tendrils show where a density ridge only barely stays above the lowest threshold. He returns to cosmology because emptiness has become a ruler. Fit the anisotropy of the void galaxy correlation function and the height of the compensation crest. Compare to mocks under trial cosmologies. The allowed band for growth rates narrows. The distance ratio between radial and transverse scales adjusts. Voids in this ledger complement clusters: the former test expansion and growth where matter is thin, the latter where it is thick. The answers agree within error bars signed by different systematics. If the universe hesitated between models in one room, the other would likely steady the hand. So far the rooms have learned to nod together. The quiet mystery returns through the door. It prefers scale. As surveys widen and deepen, very large underdensities challenge the typical void grammar. Some are composites that percolate through masks. Some align with superclusters along rims and complicate stacking. Some host unexpected interior strings of dwarves that a shallow pass would have missed. The question becomes how to keep universality where it is useful, and specificity where it is true, when to stack and when to listen to a room's accent. Dry observations resume their even pace. They call these operations reconstructions, and the word is precise: the field is reconstructed from samples not seen. They call systematics nuisance, yet in these ledgers the nuisances are the craft. Controlling them is the result. They call the profiles smooth, which they are in stacks. The single hollow is still pocked by the history that made it. He keeps one human-scale image, where the window meets the ledger. Under a quiet night, someone who has never looked at a redshift cone sees only stars. The map exists in the arithmetic of thousands of spectra they will never hold. Yet the same person shown the fan of dots and the pale wedge inside understands at once that absence has shape and that shape can be measured. A long exposure through a small telescope would show nothing of the room's outline. A chart on paper will. The pleasure is different and compatible. He lets the section settle where method, measurement and room agree. Fact redshift surveys corrected for selection and masks and interpreted with watershed and related finders recover. The Boötes Void is a genuine lumpy underdensity. Its profile, deep center, gentle rise, broad, modest compensation is confirmed by lensing deficits, low dispersion measures and faint gas traces. Stacked voids turn shape into a ruler through anisotropy and the Alcock-Paksinski test. Detail fiber collision corrections, tiling and completeness weights prevent artificial hollows. Center definitions change profiles slightly. A splashback-like crest beyond the edge is broad here, signaling maturity. Mystery whether photometric redshift void catalogues can reach spectroscopic fidelity for geometry and growth. How to keep universality where stacks help while preserving accents where single rooms deserve to speak, and how very large percolating basins alter the standard grammar. Irony's presence maps absence. Subtracting instruments reveals the sky, and stacking hollows provides a ruler, while the named voids keep their lopsided charm. The cone closes, the numbers keep their tone, and the great hollow remains most legible, not to eyes at an eyepiece, but to a ledger that prefers patience calibration and a habit of letting the quietest answers be the ones that are measured twice. He lets absence hold the yardstick because the quietest rooms are sometimes of the straightest lines. The accepted fact rests in the middle, without raising its voice. The statistics and shapes of voids test cosmology, expansion, growth of structure, and even the properties of gravity through two gentle tricks, one geometric and one dynamical. The Alcock-Poksinski test that asks whether average voids look round in the correct distance scale, and redshift space distortions that encode coherent outflows from their interiors. Together these turn a map of lack into a ruler with numbers. He keeps the craft visible so measurement is steadier than metaphor. Stack many basins after rescaling by effective radius. In the correct cosmology, transverse and radial sizes agree. If the cosmology guess is wrong, the stack looks stretched or squashed along the line of sight. Fit the anisotropy and a distance ratio falls out angular diameter versus Hubble distance at the stack's redshift. Then read the dynamical part. Coherent outflow elongates or compresses the same stack in redshift space in a predictable way. Fit that signal and the growth rate of structure emerges. In the ledger, the empty room speaks twice, once to geometry, once to motion. The lesser-known detail settles beside that ruler, like a penciled tick mark, compensated ridges just beyond void edges. The low crests where matter swept from the interior gathers serve as a second low variance feature, whose position in scaled units drifts only weakly with time. Measuring its radius across redshift bins offers a quiet evolution test that is less sensitive to the precise definition of center than the inner profile is. When stacks include giants like Boötes among many smaller rooms, the crest still lands near the same scaled coordinate, a comfort that the choir remains in tune, even with a baritone present. He lets growth feel like weather recorded on a calm day. The growth rate written Eshev is the logarithmic derivative of the linear growth factor. Multiplied by the matter clustering amplitude sate, it becomes the quantity f is 8 that many surveys prefer. Redshift space void distortions return this f8 by listening to the coherence of outward motions, modest speeds small per galaxy reliable in the stack. Because the void interior contains less non-linear complication than clusters do, Boddle. Systematics differ, fingers of God, the random inner motions of bound halos barely intrude. Galaxy bias enters but can be tamed by multiple tracer types. The remaining nuisance is the instrument of patience enough. Void's careful masks the right smoothing. In that arithmetic, the quiet rooms supply a growth note that complements the loud one from clusters, and the two notes played together tune the same instrument, the strength of gravity's pull-on structure by different hands. The quiet mystery keeps its chair. How far void rulers can push into theories beyond the standard script modified gravity with scale-dependent growth. Light relics such as massive neutrinos that damp structure differently in thin and thick places. Dark energy that deviates from a cosmological constant and alters the time dependence of both geometry and motion. Simulations that switch gravity's law or add neutrino background. Predict small changes to void profiles, alignments, and crest location.